Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Hold on. Hey, Pinky.Bandinski, did you delete those Antarctica South Pole photo ops?
Yeah.
Who said yeah?
Pinky.
But when you posted them, did you see that as providing evidence that the Earth's a sphere?
I guess it depends on what model of flat Earth you have. Like, if you believe in that thing where it's like the ring of Antarctica is like this big ring that goes around, you know. If it's that model, then I guess that going to Antarctica would prove that that's not.
Well, apparently when you go south, you know.
No.
There is no flat Earth model, and there is no globe Earth model also.
Yeah, we don't have a model. So if you go south from anywhere, you're going to end up at ice. I could guarantee that.
You'll get to the same spot because you could have multiple people.
Pardon me?
But that spot, like the ring, quote unquote, of ice that goes around, you could show that it's the same spot. So if you go south from Australia, then south from South America, if you have two people, they should get to the same spot. Or if you, yeah.
Oh yeah, I see what you're saying. Yeah, actually, I mean, if you were allowed to go there, then yeah, sure.
Okay, so the thing I posted was a expeditions to fly there or to ski there if you really want to do it.
Cool. Have you got money to go and pay for that?
No, that's what he told us to do. He told us to save up money.
Yeah, I said you guys should like choose the person you trust the most and then all save up because it's not that expensive, honestly.
Well, hold on. So this is something that actually needs to be addressed, right? So let's say I invited you to my house for a house party, right? But you were only allowed in the lounge. Would you say that then you could go to my entire house, or that you were restricted to only going to my lounge?
Well, I don't know what part you'd be restricted to go in.
Well, but that's the point, isn't it? You can't freely explore it, so you're not actually going wherever you want in Antarctica. You can't just go and check out whatever you want to do and do whatever tests you want to do. You have to collect your own wee and poo and all the rest, which is obviously very difficult. You've got to take supplies of water. It's not just the money, right? There's a lot of red tape. There's a lot of all sorts of governmental restrictions on top of that, right? So there's this kind of argument that, oh yeah, you can go to Antarctica. Yeah, you can go to Antarctica in the same way that you can go to my lounge for a house party. It doesn't mean you can go to my house.
I don't think anyone's. I mean, first of all, even if there were restrictions of where you're allowed to go, I mean, I don't know who's going to stop you if you're just wandering through Antarctica, to be honest. But
give it a go.
Do you think anybody's just wandering through anywhere they want to go on the oceans, bro?
Yeah, I mean, that's a positive claim for the globe side, right? So why don't you just prove that that's true? Go to Antarctica on your own, in your own boat, and then just freely explore and see how far you get.
Yeah, that's not our claim. So why don't the globe earthers go there? You go there yourself. So why hasn't it been done until this point in 2023? When you're here telling or whatever flat earthers to go to some place that it can't be gone to.
Wait, well, there is. I mean, I posted. I took it away. I can post it again.
The south.
It's a red herring. It's a red herring, a non sequitur, and it doesn't apply when we have dozens and hundreds of shorelines all over the flat plain. We can do local observations and show that the globe Earth doesn't exist. There's no drop over distance ever been seen in reality or used.
Yeah, that's what I was.
So for example, even if they don't allow you to go wherever you want, all you need to do is get to the South Pole. Once you do that from, say, South America, and you can fly there, then you can ask them to fly me to Australia, and then you'll see that.
Get there. Now all it needs to get to you can't just like put on an extra swimsuit and just front crawl there. There's hundreds.
And dude, and you're just presupposing the whole idea that once you're at some location, you're on the bottom of a sphere.
I know exactly. What a doofus.
Well, no,
You know
wherever
what I'm saying? The fact that
wait.
you have to start. Listen, in order for there to be a locale as known as the South Pole, not just Antarctica, not some snow island.
Yeah,
You would have to have the sphere. You would have to have the spheroid Earth in the first place.
Yeah, exactly. So maybe if the Earth just expands on infinitely in all directions, but there's just a ring that surrounds this ocean place.
No. Listen, we're not talking about. We're talking about the globe model. The globe model has Antarctica as the polar cap of a spheroid.
Yeah. So what you can.
So would you agree that in order for a place such as the South Pole to exist, the Earth would first have to be spheroid?
Oh, yes, I agree. But let's
let that sink in.
I know, but what I'm saying is, what you could do is fly from Puertos areas in South America to this one spot. Right now, this is the spot that you've been there before because maybe you can like leave something there, so it's the same spot, and also you'll just see this building's there. It's the South Pole, right? Now you fly back, you go to Australia, and then you can fly from Australia there in a similar amount of time.
Who did
that same spot? If it was that ring model, then you wouldn't be able to go to that same spot.
The spot with the shiny silver ball.
Yes.
Okay,
so basically, according to your model, that should be impossible to get to.
We don't have a model, and so if the planes are flying in level flight, that means they're flying over horizontal oceans, right?
And again, you said according to our model.
Wait, Sasha, I was waiting for him to answer that.
Oh, fine.
If planes are flying in level flight, they're flying over horizontal oceans, right?
Yeah.
Thank you. Welcome to Flat Earth.
Well, I mean, according to my model, they'd be flying over the surface of the.
According to reality, what do you think?
Yeah, in reality, they're flying in level flight, which means a straight fucking line of flight.
First of all, Sonny, give me 1 minute. Did you say according to your model? What is my model?
Oh, mine's just the regular one.
What is mine? Because you said according to your model. What is my model?
Oh, just the standard globe, Earth, all of that stuff.
You said my flat Earth model.
I meant the globe model. Just
you also quoted us.
You said according to your flat model.
I'm sorry. I didn't mean to say flat model. I didn't mean to say that.
Okay, so what is our flat model? You did say it. So what is our flat model?
Yeah, your flat model. I can understand you guys might have different ones, but the one I'm specifically addressing, well, actually, to be honest, any one that you could come up with.
Listen again very carefully. We don't have any model.
Okay. Well, I mean, you must have some.
No, we don't. No, we have no model. Period. Why do we need a model? We show the Earth is measured flat. Why? We don't need a model.
Okay. Well, I guess that's interesting. I'll try to think about that.
Yeah. What do you think about behaving of water?
Behaving of water?
Yeah, how water behaves in nature.
Yeah, that word in English, behavior, by the way, Sasha.
How it behaves? I don't know.
How what lakes when you have a lake, how lake look like?
Yeah, I'm visualizing in my head.
Think about this. What happens when you have a mirror, right, and it's curved, right? What when you look at that mirror when it's curved, what do you get? You get like when you go to like the fair, right? And you see the image all disconfigured, You've seen that, right?
Yeah.
So when you see these pictures of these lakes that are like huge, I mean, possibly even miles large, right? And you see a perfect reflection of the mountains, okay? That's not possible in a globe Earth.
Oh yeah, that's pretty good. You could probably look at the reflection of mountains and see if you could see. Yeah, I don't know. It might be I don't know if statistically you'd be able to see it because maybe just even the aberrations on the surface of the water might abstract it, but possibly that could be something to look into. That's very interesting.
There are images of that. Perfectly still waters, reflecting mountains perfectly. Yeah.
And do you know your globe model?
Yeah.
Yeah. What is the radius?
Oh, I don't know it off the top of my head. Actually, I just
Oh,
thought
that means that you don't know your model.
And you said you know, now you don't know.
Oh, well, just because I don't know this, like just
because you say you know, and then you don't have anything to provide proving that you know anything, so you don't know anything.
Well, I was just talking about that's the model I believe in.
I'm not sure it's possible that you could know anything about the globe that you speak of.
Can I just mention, every single flat earther you talk to in this chat will know the radius of the globe. Just, I know that for a certain. Like,
well,
there's not a flat earther in this server who doesn't know the radius of the globe model. So, I mean, what does that tell you?
It tells me you guys think about this stuff quite a lot. I mean,
hold on. We were Globers. We were Globers from the very beginning. That's the point. We grew up as Globers. Me until I was 58 years old. How about them apples?
But do you guys see that, like, just because if I don't have in my memory the exact radius of the Earth, that doesn't mean that I don't believe in this model.
And you're here in a flat Earth server, and you're trying to provide proof of the globe, and you don't have anything. Yeah, we understand.
Well, I don't really accept that logic, because in terms of the pure, just because you don't know one thing doesn't necessarily mean that you don't know the model. That is true, but it's also missing the bigger point. Like, for instance, if you are having like a high-level genetics discussion, or biology discussion, or whatever, and one of the two guys who claims to be a PhD in biology didn't know what an allele is, for instance, right? You would call into question whether he actually knows very much at all, because it's such a foundational part of the subject. Do you see what I'm saying? Like, some things are like squirreled away. Like, if you were to say, what's the size or how far is Antares, the star? Fair enough, probably most people won't know that. But we're talking about the Earth itself. What is the size? What is the shape? Now, people who are interested in that subject are going to know the radius. They're going to know, because it's a foundational element of that. Anyway, go on.
Well, sure. I mean, but keep in mind, I mean, I don't claim to be. I mean, I know a lot about the world just because of just living my life and such. But I mean, most people who believe in the round Earth model, like, just seriously pick anyone really from the main street, like Neil deGrasse Tyson, all these people, just anyone, like Sam Harris, Joe Biden, Donald Trump, anyone. Like, if you ask, the round Earth model is still the one they believe in, regardless if they know the exact. Number.
Yeah, but
they only have a belief, though. It's like a religion. They don't have any proof for the globe. If there was, you could show us a test that would show specifically where the geographical location is repeatedly. This drop-over distance would have to be there on the surface of Earth, and you can't show us that, or any motion, or that gas pressure can exist without a barrier next to a vacuum. Thank you.
Question: if we have the size and radius, can we check the physicality of the Earth?
The size and radius.
Well, what he's saying is, if you know what the proposed size is, can you test that?
Oh, the radius of the Earth?
Yeah, can you test it? So, for instance, if I was to say to you that all Lamborghinis are blue, can I actually go out and test that? Will you find a yellow Lamborghini and then not all Lamborghinis are blue, right? So you've got a radius, and so it must be that radius, and all tests must conform to that radius. Can that be tested?
Yeah.
Okay.
But also, I'm just realizing you guys are like jumping on me for not knowing the exact radius of my model, but you guys don't even have a model.
We don't have a radius. We don't believe we live on a ball.
But doesn't matter.
I couldn't even ask you, like, what's the latitude, like, what's the distance of going around, like, from south, like, on the latitude of Australia.
So let's try and address that then. So, how much funding from governments was put in by governments into flat Earth research last year?
Zero.
How much was put into globe Earth research, rockets, space missions, all this other shit last year?
$10,000 per second.
At least 70 million per day.
Yeah, billions is the answer. So obviously there's going to, if you've got like hundreds of people on full-time salaries to come up with this stuff, then obviously that stuff's going to exist. So I don't really know what your point is.
Oh yeah, I guess. Oh, I mean, my main point was, you don't even have a model. But to be honest, admitting that you don't know something is like actually the right thing to do.
Okay, Pinky.
It's a true thing.
Okay, Pinky. Tell us where. Do you know where, when, and how Earth's curvature, any time in history, was actually directly measured?
Can I just
wasn't the first person to do it for like some ancient Greek person that used like an eclipse?
Oh my God, sticks again.
Yeah.
No. He's looking at someone. Look, can I just ask very quickly, Pinky? Do you think that if a government agency paid, I don't know, 50 people full-time salaries to come up with a flat Earth model, that they could do it?
Yeah, it sounds like a really interesting problem to do. I mean, possibly, I don't know, maybe not, because obviously all the claims you're making might not mesh together, so it might be impossible. But it would be very interesting to try. Because I was thinking before when you were talking about the like using a sextant, and then someone said, "Oh, but we don't even think Polaris is a certain star. It could be just like curvatures of light. So that's why on the flat Earth,
Holy crap! You totally don't misrepresent me, bro.
Oh. Well, no, I'm just saying that's an interesting idea, and you could come up with some model where all these things.
That wasn't my idea.
I know this is just my.
But he's trying to answer my question by, and I think you're being.
No. I think if you're right, Crypto. Just because you don't have a model doesn't mean that it's bad. Like, yeah,
it just means
more
funded, right?
Yeah.
So I would suggest that you should ask the governments why they're not researching this if it is true.
Does the globe even have a model? I don't think it really does. I think it's all over the place.
Globe
has no model. That's kind of the point I'm trying to get to. Is like, if you were to throw money at coming up with ideas, well, guess what? You're going to end up with ideas, right? Obviously. No. But what does that prove?
I don't know.
Right.
And maybe you want to compare that flat Earth model with the globe Earth model, and then you say this cannot work on the flat Earth model. But this is like a wrong. Well, let's check the surface and realize is it curving or not. If it's curving, there is no point to be flat, and everything is fine.
What do we need a model to begin with? The very thing that we should test is reality. We don't test models; we test reality, right?
We actually can't test a model. A model is only useful if it makes reliable predictions, but it still doesn't mean that it actually conforms to reality.
Well, you have a model, and then you do a bunch of tests and see if the evidence aligns with it.
Yeah,
but I suppose
you can test
right. But I could come up with a model that says, I don't know, the temperature in England. If you give it a time delay, the temperature in England correlates with the rising of the sun. Therefore, the dropping of the temperature causes the sun rising. And obviously, the night time causes a lower temperature. And so I can prove that mathematically there's a correlation between the lowering of temperatures and the sun rising in the morning 8 hours later or whatever. So that would be valid for making mathematical predictions. But does that make any sense to you?
Oh yeah, you can. I mean, the correlation would be there, but then like coming up with causation requires you to understand it at a deeper level, because you need to understand the mechanism of what's going on. But like,
no, it doesn't. No. It doesn't require a deeper understanding, because that would just be doubling down on the idea and thinking you understand it better. What it actually requires is for you to manipulate that and observe what the manipulation does. Because otherwise, all you can do is say that X correlates with Y. And that's what you can do with the sky. Because you can't take the sun and go, oh, I'm just going to move it, see what happens. Right? So the only thing you can do with the sky is go, well, that correlates with that, and that correlates with that, and we've got all these correlations. You can't find out any causation.
Yeah, using that scientific method that you just explained, like do an experiment where I decrease the air temperature and see if the sun goes down. That's using that sort of experimentation is untangling all these different correlations to get to a better understanding of it all. But there's also other ways. Like, for instance, if I just I know that this is probably not going to go well over with you guys, but like, if I, send a satellite to space, and then I just imagine if this is the case. Maybe I should use a different example, but if you send a satellite to space, and then you see, oh, right, I can see the terminator of the sun's light on Earth. That's what's going on. Now I can see, oh, of course, there's less heat, thermal energy, so the temperature is going down. You can understand it through other means than just, changing variables. Like, if you get a better understanding through many other different pieces of knowledge, then you can put things together like that.
And how I can check that understanding?
Yeah, I mean, that's absolutely true. If I was to get my own tin can and shoot it up into space and look at a globe Earth and look at the Terminator line, then I'll just have to say, well, that's going on. Similarly, if I was to go to Azeroth and meet an orc, and then we go and buy a dragon, and then we ride that dragon into, I don't know, some big ogre's lair and slay the ogre, then you'd have to accept that dragons exist, orcs exist, and ogres exist, right?
Yeah, if you do that, I wouldn't say with 100% certainty, because like there's very few things in this world that I would say you would know for certain. But like, it appears, using the standard evidence that, the standard sort of rules to believing
the
stuff.
point I'm trying to sorry to interrupt. The point I'm trying to get to is that you're already assuming the truth of your assumption to make the argument in the first place. But the truth of the assumption is what's in question. So you can't assume the truth of the conclusion. This is why it's begging the question. You can't assume the truth of the conclusion as the premise.
Are you talking about the satellite going to space thing in regards to that? Yeah, so that's exactly why I was hesitant, if you remember, to use that example, because by making that example, I wasn't making any claims about the flat Earth or anything. This could all be in a hypothetical universe. The only thing I was doing was explaining how you can use more observations and a better understanding of a phenomena to understand it. That's why I knew you would go there. That's why I had to. I was going to try to think of another example I could use in something more terrestrial in terms of understanding a situation. But yeah, so when I say that, I agree that all would be in a hypothetical situation. I'm not saying.
Well, it's worse. It's worse than a hypothetical. It's actually making the question. It's a very well known fallacy, right? And I'm not trying to be a dick to you or whatever. But it seems to me like you kind of already knew what you were saying was fallacious. So you should already be thinking, is what I'm saying fallacious? And if that's the case, why do I think it's true or valid? That should be the first thing you should be asking yourself.
Wait, with regards to what?
With regards to sending a satellite into space.
No, that was just. I don't know exactly how was I fallacious with regards to that?
Because it's begging the question. If we
I know.
Accepted that the Earth was a ball and that you can send satellites into space.
Okay, never mind. I already answered this. That wasn't supposed to be any proof that the Earth is round. I was trying to just explain how you could, if you had a situation where there's cause and effect. It doesn't have to be the Earth.
Look, dude, I understand. Trust me.
Oh, okay.
I understand fully what you're doing, and it's not a problem. But all I'm saying is if we already accepted those things were true, then you wouldn't have any reason to present the argument in the first place, because we'd already be agreeing with you.
I don't think so, because in that moment, if I had, instead of talked about satellites, talked about, now I have to come up with another one. Cause and effect. Okay, like if you've got
cause and effect, there is no cause and effect. It's a shape.
Listen, man, let's put it this way, right? So, if everyone in here already accepted that satellites could go to space and that satellite going to space could view the Terminator line on a ball Earth, right? We'd all already be globers, and you need to be making an argument for the globe based on those things.
I know.
Okay, that's what I'm saying.
It doesn't matter. Let's just move on from this. I mean, I've already answered this a few times. I think we should just move on.
Yeah, but I feel like you don't really get what I'm saying, but it's all good.
No, I do get what you're saying. But just okay, go back, rewind, and instead of me talking about the satellite, instead, because I was very nearly going to do this, and I thought I'll just give it a go, but I guess it didn't work. Imagine a new circumstance where you're trying to figure out cause and effect, like say maybe like the classic one. Is it if a person's black, then they're more likely to
Oh god.
have a.
Here we go.
No, see that one I can't do either because that's going to annoy people. How about this? I'll try a different one. We've got. I now have to think of.
That's like ice cream and murderers to me.
Yeah, that's exactly what I was going with.
Why to imagine? Let's go directly to the proof.
Okay, so
to be honest, I haven't even started talking about flat Earth.
No,
That's
global.
the main thing.
No
yeah,
flat
we need
Earth.
to talk
Global.
about it first. We need
Well,
to
you
talk about
presuppose the South Pole is.
No, I did.
I would like to know why we have so many satellites, we have so many missions to Mars, we have all this bullshit, and yet we have no fucking pictures of the Earth. Like, none. They're all CGI.
Well, I mean, you know why that is. It's not what they're saying it is. The Earth, that is.
I know that, but I'm just wondering, like, how do Globers not see this?
because they don't want to.
Because they want to hold on to the fantasy. Maybe they haven't been presented with the evidence, and when they are presented with the evidence, maybe they want to try and ignore the evidence to believe that they were right all along, and so was everybody else, and he's going to still remain on his ball, whoever that person is. What was the conversation earlier with you, Pinky? What were we even talking about?
He was going to, like, some racial stats. I was like, what?
Oh, just trying to think. Causation, correlation.
Causation and correlation are two different things. If we want to find a cause of a phenomena in a physical natural world, well, we can science the shit out of that. That's cause and effect based. What caused that to happen? You kind of half building a hypothesis, but it's interesting when you have to beg the question when building your hypothesis as well. But what are we trying to prove in a cause and effect relationship, mate? Or what assumption are you going to have?
No, I mean, so I've talked. So this is my first day on this channel. I've basically I was in chill text for a bit, and of course, I understand the need to not beg the question, like assume a spherical Earth when I'm making these arguments. I did actually make that mistake once with someone. I think he's in this chat. With Old Hoss. When we were talking about the horizon, that's one mistake. Just because I'm so used to thinking of the Earth as spherical that I did do that, like I built in. But most of the time, you have to trust me. I'm pretty, cognizant of, or at least I'll try to be, not obviously assuming things. And so with the Antarctic thing, all I was doing with that was just showing that given a certain model, now you guys don't agree on the model, but given the whole Antarctic ring thing, that would be a way that you could disprove that, and it would actually show more evidence in line with the spherical Earth thing. I certainly wouldn't be, traveling to the South Pole doesn't assume that the Earth is globe, for instance. You're just traveling to the South Pole. Oh, no. Okay. I just heard as soon as I said it. No, traveling to southward continuously doesn't. That's what I meant by that. Yeah.
It's interesting that you're bringing up traveling and navigating across the Earth. Has anybody brought up with you the subject of navigating the Earth with the stars?
No.
No.
No one's spoken to you about navigating the Earth with the stars. Have you ever heard about navigating the Earth with the stars, better known as celestial navigation? Have you ever heard of that?
Yeah.
Awesome. So, do you have any understanding about it? For example, if I was to ask you what an elevation angle was, would you know what that was?
Yeah, I think it's the apparent angle between the horizon and some celestial body, possibly.
Yeah, exactly that. So we gain an elevation angle from a known celestial body. Let's call it Polaris, and we measure an angle to it. We basically build a triangle. Let's start that triangle from us. You know what a sextant is, right? You've heard of that before, an angle measuring device?
Yeah.
Yeah. So that's basically how we're going to be drawing our angle. To keep everything simple, we're going to put the sextant on the floor, because there's a couple of corrections that you're going to have to make for your altitude and this, that, and the other, but ultimately all of those corrections are going to put you back on the floor. So if we can imagine from the sextant, you draw a line straight up to Polaris. from Polaris, you draw a straight line down to the Earth, and you draw 90 degrees there, and a straight line from that ground position GP of that star to you. Would you agree that we've drawn a triangle?
Yes.
Awesome. Can you measure an angle if one of those lines is curved? In actual fact, if you have one curved line on a triangle, would you agree that there's two angles that you can no longer read or measure?
Well, I mean, you can still draw a straight line from your position to the point where the horizon disappears, but there's also the curvature of the ground according to my model as well.
Yeah, so according to your model, there's curvature to the ground, which means the line between your sextant and the GP of the star, which in Polaris's case can be, I don't know, 3,000 fucking miles away, right? Because that's how we get our latitude lines. But Polaris can be 3,000 miles beyond the horizon, and there must be a straight line between you and the ground position of it. Underneath Polaris, there's 90 degrees. In actual fact, there's 90 degrees under every single star. So for celestial navigation to work, we use triangles. If the surface of the Earth was curved, we wouldn't have 90 degrees underneath Polaris or any other star, and we wouldn't be able to measure an elevation angle up to that star because the baseline, the curve of the Earth, would be fucking up our triangle. Do you understand that?
Right, so I think I can post it. If I post a picture really quickly in live stream voice chat, I'll show you what I mean. So if you see the so I just posted it. It's if you see the diagram, so yeah, you've got S, which is the curvature from where you are.
Yeah.
Then you've got the D, which is from you, and H could be very small, like it could be a meter off the ground. You know, it's just wherever you're holding your sextant. I mean, I guess if you're on the very ground, it's kind of difficult to understand, but yeah, usually S and D will be very similar. But there is, I think, what the whole point of the sextant is measuring D, not S. Now, and also, now when you say ground point,
sorry,
yeah, sorry.
What the sextant is measuring is the elevation angle up from the horizon to the star.
Yeah, so from D.
So let's put the ground position of your triangle on that curved surface. Do you understand on that curved surface you can't read a 90-degree triangle? You understand that, right? Underneath that star is the ground position. That has to be 90 degrees to you. Not just that one star, but if you turn around to that star over there too, and in fact every single one of them, let's say 1,000 stars that you can read overnight will have a 90-degree ground position to you, straight line. So you can measure an elevation angle up to it. Now, like I said, that star can be 3,000 miles beyond the horizon. This is how we got our latitude lines, for example. You started speaking about navigation and going south. Imagine we're underneath Polaris, and Polaris has got a 90-degree angle, and you can point straight up to it. Go away, go south, measure the angle, decline until it reaches 45 degrees. 45 degrees latitude. Then keep going south away to 0 degrees. That will be the equator, 0 degrees latitude. Now, you'll understand that every single increment along the way that we measured an angle up to Polaris to get the 45 and the 0 and the 90 and every increment in between, demonstrating that even in this instance, we measure angles to stars to navigate to them. In this instance, I've pointed out to you how the globe Earth requires a flat Earth to get latitude lines from elevation angles to Polaris. So, to understand celestial navigation requires the Earth to be flat, because if the Earth was a curved surface, we wouldn't be measuring elevation angles up to Polaris to get latitude lines to navigate the Earth.
Well, I mean, so I
get what you mean with your diagram, but that's not how celestial navigation works.
I know. The first diagram I posted isn't about celestial navigation at all. That's just finding the distance to the horizon. But we're not talking about the distance to the horizon, so it's a separate thing. But anyway, I mean, I was just showing the difference between D and S, like, you know, a straight line. So you can get an angle. Fine. But the second diagram I posted, I just typed in on Google, how does a sextant work? And so I think this is basically what's going on. I think the Polaris is so far away that it's not really like there's a ground point that it's above the Earth. You can say, I mean, it's not like it's hovering like it would be over a flat area. It's just so far away that the light...
Incorrect. You're incorrect.
I know,
Every
I know,
single
I know.
star
You
has.
think I am.
Why you went? So why would you even say it if you know that you're incorrect? Every single star has
No,
a ground position because
I
every
know
single
that.
star.
According to
Okay.
your model, wait
So
1 second, 1 second. I'm not
no,
talking about
no,
according to
no,
your model. This image that I
no.
posted is according to the whole the spherical Earth model. In which case,
Uh huh.
with the spherical Earth model, I don't
Uh
really
huh.
know what a ground position would be. It would just be wherever it's tangent to the Earth. Although I suppose Polaris is probably tangent to it's the North Star, right? So like 90 degrees.
Let me ask you this question:
Yeah.
Can you read 90 degrees if one of those lines is curved?
Um. So
Can you measure with
wait,
a, can you measure? Can you measure with a protractor, an angle measuring device, 90 degrees if one of those lines is curved?
are you talking about in relation to the second model I posted? I mean, the second picture. I
I'm
posted?
I'm talking in relation to a fucking triangle, a protractor, and measuring an angle, and relation to the question: Can you measure an angle with a protractor or an angle measuring device if one of those lines is curved?
Yeah, I wouldn't know what that would mean. So I guess the answer is no. Yeah.
You wouldn't know what that would mean. Have you ever
No,
used a protractor?
no. I agree with you. I'm saying like if a line is curved, I mean you can measure an angle at a point where it intersects another line. But
Yeah, but we don't do that when
yeah,
we're talking about measuring an angle with an angle measuring device. We don't plot a point on a curved line and measure an angle to it. For a GP of a star that can be 3,000 miles away, that line, straight line, has to be straight. You
right.
don't plot points.
So I would well basically I would say I don't think any of the lines that I am measuring with my sextant in my model are curved because you've just got a line from your eyes to the horizon. That's a straight. You can point a laser at it. Then you've got a line to Polaris, and then you see the angle between them. So there's no
Straight
curve.
line. Yeah,
You
welcome
have
to
straight line. You're using the straight line on the surface of the Earth and calling that the curve.
No, I'm saying if you look at the first image I posted, I'm talking about D, that which is a straight line.
We are speaking about reality, not about drawings.
No, but that's how you use a sextant. You point it at the
No.
horizon.
No.
Right, I'm going to have to do this again. Because I get that you're going to be pointing the sextant at the horizon with your horizon mirror. That's fine, not a problem. That's going to be where you are going to be measuring your angle up to that star. Within your calculations, this is why I put the sextant on the floor, to make everything really simple, but fuck it, we'll do it anyway. Within your calculations, you're going to want to subtract your altitude above that curved surface, so you are reduced down to, 0 altitude. So there is a straight line between your sextant, which is now on the floor, and the ground position of the star, which can be over 3,000 miles away in the case of Polaris. Underneath Polaris is a ground position. It's plotted point on the surface of the Earth, where you will read 90 degrees. So you've got a straight line down from Polaris, 90 degrees. You've got a straight line to your sextant, and then you measure your angle up to it, requiring the surface of the Earth to be level, because if it was curved, there wouldn't be 90 degrees underneath Polaris to begin with.
Oh, I see. You're saying if you go because the point on the Earth, if it's spherical, where Polaris does have that 90 degrees spot,
Okay.
it would be impossible.
What about the stars of the Big Dipper? Because yes, you can't read 90 degrees underneath Polaris, but remember I said every star. Now it's kind of hard to get one 90 degree on a curved surface, but we're going to talk about every star now. Because every star has got a ground position, so you, with your sextant, can read an angle to it over the course of a night, and every star will have 90 degrees. That's impossible on a curved surface. You can't get one, let alone many.
So if you're navigating in this way, like as we do with right triangles, if the surface below you was indeed curved at the prescribed rate, then you could never find your location accurately, let alone thread the eye of a needle off in the distance across large bodies of ocean, like across 2,000 miles of Pacific Ocean from the California coast to Hawaii, or even further from Hawaii onto further islands, which could be 4,000, 5,000, 6,000 miles across ocean water, and find your way to this little tiny island accurately even most times without seeing it.
Wait, why?
A lot of these places are covered with fog. This is how these things were done in reality with navigators. That's why.
I don't understand why.
Okay, go ahead.
Why you couldn't use a star? Of course, if it's not the North Star, then over the course of the night, its position in the sky will change. Is that what you mean?
You cannot.
Not exactly. No, what we're talking about is we're practically traveling across the bottom leg of a right triangle. That has to be a flat surface in order to have an accurate location. The thing is that you're actually finding out where you are located according to this GP of the star at that angle. The bottom leg is very important, so you can't have a curve be trying to calculate with a right triangle with your actual sighting and traveling across a surface that was curved. You would lose your way.
Wait! I think I get what you're saying. Are you talking about the to find the distance from yourself to the GP?
Right.
Is that what you're saying? Oh, okay. Right. Yeah, so if you look at the so the way that latitude is defined is it's not defined as distance from you to the GP. It is literally defined as the angle between the horizon and
there you go. There you go. So it's an angle then. See, this was my point on why. But hold on.
Sorry.
It's an angle. As long as you say angle, you require the Earth to be flat. See, this is the instance as well where the globe Earth model requires the Earth to be flat in the first instance to get latitude lines to begin with.
No, but it's actually not. I disagree with what you're saying. I'm not saying it's an angle. It is a location on Earth, but it's defined by the location where that angle exists.
Do you know what 90 degrees, 45 degrees, and 0 degrees are when relative to latitude? Do you know where 90 degrees is?
I'm sorry. Relative to
90 degrees north. 90 degrees north. That's underneath Polaris. 0 degrees. Yeah. Where's that?
I'd hope it's right on top of the North Pole, but there could be a corrective factor. Obviously, Polaris isn't exactly above it.
It's the equator. So 90 degrees underneath Polaris. 0 degrees at the equator. You notice I'm saying degrees is angle measurements. That's why they're called 90 degrees and 0 degrees. They're fucking angle measurements. You require the Earth to be flat to get angle measurements to Polaris, to get latitude lines to navigate across the Earth, because the stars are constant. They come around every year and we know exactly where they are, time, day, month, second. And because they do that, we can figure out where our longitude and latitude is. Our longitude and latitude come from elevation angles to Polaris. Navigation of the stars requiring the Earth to be leveled disproves the Earth being a ball, because we wouldn't be able to do that.
No. So they are it is a measure. Like again, you can just look at it and see the diagram I posted. But essentially, it is a location on this sphere. If assuming it's a sphere.
No, it's not.
But it's
it's not.
Assuming the model is correct.
No,
it is a model.
What model?
The spherical Earth. It is
okay. Can you post that in live stream for us? We want to see the spherical model, and we're going to head back to those angles because they're not just any old angles; they are elevation angles.
Yeah, I know. I'm just saying if you give someone a longitude and latitude, it defines a spot on that.
Now, how do you get the latitude on a sphere?
Using a sextant.
You can't do it.
Not on a curved line, which is what I've been trying to point out to you. Sorry, Kiwi.
You can't do it. Because define an elevation angle.
Wait, I think instead of answering that question, I'm just going to try to understand what you're saying. By Jedi, I mean Jedi. He's saying, don't you agree that if I draw on a circle a latitude, it defines a series of locations in a circle that goes around the sphere, assuming if there is a sphere.
What is he talking about?
What? I don't know. He wants me to agree that if we draw lines around a circle, that the Earth must be a ball. I want you to understand.
No. I'm assuming that it is a ball. Then
don't want to do that. I want to show you that without any assumptions, we measure angles to stars to figure out our location on the Earth. No assumptions needed. We use triangles to do this. You can't do this with a sextant, as you've pointed out, on a curved line. You will bastardize the 90 degrees underneath any fucking star you want to choose from, and also the elevation angle, because you wouldn't be able to measure that, would you? Because your line's curved to the Earth.
But wouldn't you agree that there exists spots on this world where you using a sextant will give you the the same value, right? I mean, that's what a sextant does. So I agree with you there.
Yeah.
It shows locations, right?
It
No.
measures angles.
It measures elevation angles.
Yeah, it measures elevation angles and
Okay,
all
define
the
an elevation angle.
elevation angles in certain locations are
I'm
the
going to
same.
ask you one more time. Define an elevation angle. It's very simple.
Wait, I already have. I don't know if you've been listening to this conversation.
You already have. Then what is it?
It's a distance. It's the angle from the horizon to a celestial body.
Nope. I got it at 21 minutes after the hour. Elevation angle from radartutorial.eu. Elevation angle is the angle between the horizontal plane and the line of sight measured in the vertical plane.
Those are two straight lines.
Where's the horizontal plane at on the sphere?
I think the angle you use in a sextant is to the horizon. I don't know.
What?
Oh my.
We just said this. This was an open test question. We already gave you the answer just a couple minutes before of what an elevation angle is. And when asked, you couldn't even recite it.
You're confused on what an elevation angle is.
Oh yeah, that's wrong.
That horizontal.
Go ahead.
All I was going to say is that horizontal line is between the sextant that we put on the floor earlier and the GP of the star, which could be Polaris 3,000 miles away. That's the horizontal plane, that bit there, that straight line. Do you understand yet?
I think I'm missing what you're talking about. I mean,
do we need to go through what a triangle is again? 3 straight lines meeting at 3 vertices, and where you can read 180 degrees on the interior of that triangle. That's what a triangle is, right?
Yeah, I know what a triangle.
Yeah, good. So if you curve one of those lines, you cannot measure no longer 2 angles along that curved line, right?
Sure. Yeah, I agree.
Good. So if the surface of the Earth is curved, that curved line, then your horizontal baseline is curved and not straight. You require it to be straight to measure 90 degrees underneath the star, whichever one we're going to talk about, so you can get an elevation angle up to it. We draw a triangle. We couldn't draw a triangle if the surface of the Earth was curved.
Yeah, but I've already answered this. Do you know what I'm going to say next? I mean, because I have said.
You know what I'm going to say? Welcome to Flat Earth. Snacks are in the back, bathrooms on the left, DJ spinning requests, baby.
That's perfect timing.
Yeah, it is. That's what I'm going to say. Unless I don't know, unless you're going to redefine a triangle.
No.
Hey, smoke him if you got him.
I mean, I'll try to understand. I mean, I'll just say it again. I mean, like I said, it's between the horizon, which is a straight line, and the.
I'm already smoking them.
We've already debunked you.
Yeah.
The fat lady already saying, I'm already smoking mine.
Yeah, this is what I'm going to do. I'm going to try to, because I'm not understanding what your point really is, to be honest.
The point is, it's the angle between the horizontal plane and the line of sight, measured in the vertical plane. That means the hypotenuse is the elevation angle off the horizontal plane. You can't get a 90-degree angle off a sphere. It's impossible. Go to AutoCAD. Do you know what AutoCAD is?
Yeah, yep.
Draw an angle, a right angle triangle on the sphere, and then give me the angle between the hypotenuse and the adjacent. Tell me what it tells you.
Dun, 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 dun.
I think so. Yeah, that is. I guess if you're standing right on the North Pole,
no.
How are you gonna get an angle?
Doesn't matter.
I mean,
what do you mean North Pole? Where did that come from?
Presuppose the North Pole again?
Where did that come from?
No, you're right. You're right. I should in all of these. Whenever I talk about what's going on, I should say in this model if you do this or in that model.
No, yeah, I forgot about that. Let's get back to that.
Your brain.
You said you had a sphere model. Can you post that in live stream? we'd like to see that.
Yeah, let's see
Of
it.
course, just so you guys know, though, you can, even if you have a sphere, you can obviously have a 90-degree
Can you show us the
No, you
model?
can't. No, you cannot. You would fail third grade geometry.
What? No. So it's just cool. So it's like
We'll
you
get
know, like
back to your model in a
Li-
second.
listen,
You would fail
Playboy,
third grade
it's
geometry.
just called like
Hey.
a tangent line. It's
It's
like
not a tangent. Show us the tangent mirror in the sextant.
so the tangent line on the surface of where you're standing
Show
on
us the
a
tangent mirror on the sextant, please.
what's a tangent mirror?
shit.
You're going to
Hey,
need a
Playboy,
tangent mirror on
Hey,
the sextant to give a tangent line.
Put your sextant on the floor. It removes the idea of your tangent line. I tried to point this out to you earlier. If you're at elevation, you're going to draw a tangent line between the sextant and the horizon. Your calculation is going to take you down to 0 altitude above the surface of the Earth, which is why I put the sextant on the floor to keep everything fucking simple for everyone.
Yeah, Playboy. You
So
can
I guess
still
that's
show
what
us-
you can
you
think
could just show us your. You could just show us your model, Playboy.
So
Yeah,
so I
let's go to
guess
the-
so. I guess what a sextant's kind of approximating is
No, where's your model?
assuming.
No,
I'm telling you
where's
the
your
model.
stop? Where's your model?
I'm telling you the model. I'm assuming in this is the global model.
Holy
Yeah, let's
crap.
see that.
If you, I posted a picture of it so you can see what. I'm
Oh,
talking
really? Wait, hold on a second. What's the time?
Anyway, the sextant seems to approximate the different. the distance
Anyway,
between
your
the-
ass. Where's your fucking sphere model?
You don't have a model.
Anyway, bullshit. Post your sphere model again right fucking now.
Wait,
Yeah, let's see the documentation. We want all the white papers. Come on, get to it.
so I posted the second image I posted is what I'm talking about. Is that
Post it
what you want?
again.
Okay.
Should be larger than the Encyclopedia Britannica.
I think it was at 10 after the hour, guys, if you want to scroll back up and see. I think it was at 7:10 that he posted it. If I'm talking about the right one.
Yeah, you are. I posted it again though, so that's all it is.
That's your
Where is it?
model.
Well, yeah, that's the from the side view in 2 dimensions. You can see how it seems like what the sextant's doing is approximating the tangent.
No. We've
line
already
to
been over
the
the
sphere.
sextant. We already been over the sextant. I want to see the model, and you said you have it in here?
Wait, what do you mean by model exactly?
No. We're going to get to what you mean. This isn't a fucking scientific model.
You don't even know what a model is, bro.
Define a scientific model for us, please, with citation.
Okay, I'll grab one.
Yeah, please.
By the way, you said that I'll just grab one. Like they're laying around everywhere. This will be fun.
Would you please bring us the model?
Who is this bullshit from
So it's
anyway? What's
We-
this
anyway.
bullshit? Where'd you get? So the 90 is only at the North Pole.
Isn't that where the 90 is?
This is like a walking non sequitur. Like what the a moving target of a non sequitur. This has nothing to do with how the sextant works. Do you realize this?
Oh, that's what a sextant's measuring.
No, it fucking. You have no idea. When you're traveling across the freaking oceans, do you get that part?
So you can only get lost and at the North Pole.
Well, you couldn't even. No, you wouldn't be able. You wouldn't get lost because I think you'd be able to approximate the distance.
Oh,
Holy
Fuck it.
retard. Look, we
You
know
can't
water doesn't do that. Water doesn't wrap around. I'm sorry,
You're not getting it. You're not getting it. Now hold on, Sonny. He's not getting it. Anywhere you are on the Earth, you use a sextant to get your position fixed by using elevation angles. Not you. According to you and your fuckwit model here, you can only get lost at the North Pole to have a 90-degree angle. You can't get lost anywhere else because you're screwed because you can't get a 90-degree angle. Follow?
I don't think you'd get lost at the North Pole. I think it's still.
You said that again, you dumbass. You're not getting it, are you?
No, I'm not sure I understand what you're saying.
Do you, in your depiction on your squirrel model that's not a scientific model, you have 190-degree angle with a guy standing on the North Pole. Let's say I'm near the equator and I take an elevation angle to get a 90-degree. Where can I get that from?
Oh yeah, there wouldn't be a 90-degree. They would
Then
just
you're
be
screwed.
No.
But anywhere other than the 90, anywhere other than the 90,
Every star. Every star.
You're screwed.
anywhere other than the North Pole, you'll get something other than 90 degrees. That's the whole
No,
point.
then you're screwed.
Why are you
Welcome
screwed?
to Flat Earth.
If you
Wait, why are
move
you
away
screwed?
from the north, you will get to 45 degrees. Further south you go to 0 degrees. We'll call that the fucking equator. You might go beyond the equator, not be able to see Polaris anymore, but you're going to fucking find an elevation angle up to one known star. In fact, you can do all of them. In fact, every single ship at sea is going to be measuring an elevation angle up to every single fucking star, requiring there to be 90 degrees underneath that star in a straight horizontal plane. The plane of the Earth to the sextant we put on the floor to fucking ruin your tangent line.
Yeah. And using that for hundreds of years to accurately go to the same place accurately. Like I said, so a lot of times without even seeing the coast because it's stocked in with fog. Sorry, you lose.
Is it possible that horizontal plane could be flat?
Wait, so Jedi, I just want to talk to you really quickly. The horizontal thing. So say if you're at 45 degrees, if you know how like if you have a plane and you put it against the sphere, it touches the sphere at one point, right? That's where you are. That's the plane.
What sphere? Hold on. That's the whole thing. That's the whole thing in contention. No, what sphere?
Wait, so I'm just saying, assuming my model is correct.
No, we're not assuming. You haven't shown a model. So what sphere?
Fine, I'll stop using the word model. Assuming that the Earth is
wait a minute.
low.
Where's the measurement of curvature? If the sphere should drop over a certain distance, where's that? I need that repeatably done. It should be the one that has a Nobel Prize attached to it. Should be easy to find. Should be everywhere. Please do show that.
I'm gonna try to understand what you mean. You need a measure of curvature.
Yeah. Well, hell, a ball is supposed to drop over distance, is it not?
What does that mean? A ball is supposed to drop over distance.
Okay, you don't understand a ball. If you're on the surface of the ball, if you move anywhere on that ball, it drops in elevation.
You mean it gets further away from Polaris? You mean
when you get holy crap? We're on the surface of Earth. On the surface of a ball. You're on the surface of a ball, not up in the sky above a ball. I'm talking. You're on the surface. If you're on that surface,
wait, I'm sorry. Are you assuming a flat Earth in this?
No, God.
No.
Right, hold tight, Sonny. Let me help.
Okay, go ahead.
Right. If you put your finger on top of a ball, let's call that position A. You move your other finger along the surface of that ball, let's call that position B. Between position A and position B has dropped from position A. Let's call position A you on top of a ball, and that will be B. Anything over the distance of that curvature would have descended from you.
Yes,
right?
Yes, I agree. Yes.
Good. Okay. Awesome. So on this ball, it has to drop over distance. So that would mean it would be easy to test, and it would have been done over and over and over again, because you would have to do that for every single thing you do. And it would be you would adjust for this in any kind of operation you were doing above the surface. Let's say flying at high speed, supersonic speed.
Oh.
So hold on. So where is this drop over distance been documented any time in history that has been directly measured to curve down on Earth? When was that done?
Okay. So I see what you mean. So I can try to think of something to answer that, like measuring the drop using.
Listen, I don't want you to think about something. No, I want you to give us the exact documentation of when it was ever done, anytime in history. A direct measurement of curvature on the surface of Earth, let's say over water.
Yeah, including drop. That's something I'll try to get back to you on. But just so you know about with the whole sextant thing, the sextant doesn't account. It doesn't need that drop. It's because it's not measured in regards to that. It's measured as a.
It's related. You don't understand the relationship between the horizontal situation and water. to the sextant. You don't understand how that apply, how profound that is, how that applies to traveling across the Earth. You don't see that it's correlation. Like
you're
traveling.
I know you're traveling across the Earth.
Listen, you're traveling across horizontal oceans. We know that's how water behaves. It's measurably so. And if water was curving around the ball, it would be easily measured based on the metric they gave us. Do you understand that part?
You're saying that with a sextant, it would show up.
I mean, no sextant, man.
No sextant, just all the stuff. Okay.
Just geometry. You can go to Google and find out what is this radius, and then you will find out how much drop over distance you have with your elevation. That means if you are, I don't know, if you're on a mountain, if you are on the ground, they will tell you how much you can see on the globe, and there is a formula for that. There is not our math, that is the globe math. And you don't know that. That's the problem also.
Right. So you don't know what the consequences are at the surface. So I'm going to just bring it in to you at 3 miles away. That's 72 inches or 6 feet of elevation drop. Now at 5 miles, it goes all the way up to 16.67 feet of vertical drop below your line of sight, which is a straight line. You only see a straight line. You don't see around curves or corners. You don't see like that. Nobody does. So, sorry to break it to you. That's cartoon logic. But anyway, so
we'll say really quickly, we can talk about this, and I'll try to think of some ways in which you could measure that drop and stuff. But just to reiterate, nothing about using a sextant.
It should have already been done. It should have already been done.
Nothing about using a sextant has anything to do with that drop.
Yes, it does. No, because you can't do it without a flat adjacent. It has to be a horizontal plane that you're starting from to get your 0 point, or the elevation angle is incorrect, and your location is incorrect as well.
Okay, so if you look on the picture that I posted, it shows the different the different 0 points, the different
no, it doesn't.
Horizon points.
No, that's this. You don't even understand the object.
Really quickly. Allow me to just quickly explain. So you see how when you get to different latitudes, every single one of those so-called lines to the horizon is
How'd you get to
different.
Latitude?
How'd
you get different latitudes?
Oh my God!
How'd you get different latitudes? How do you get a latitude on a globetard?
It's in the diagram.
How do you do it?
Wait. Let's just assume I know. I do know. I think you know as well, right?
No,
so let's just assume I know.
You tell us that.
No. How do you get a latitude on a spheroid?
The latitude is the using a sextant, right?
You can use a sextant, but any tool in the box that measures an elevation angle, you'll get your latitude, right?
Like a fifth grade school protractor.
Okay, define elevation angle again for us. I got it at 41. I'm sorry, 41 minutes after the hour.
Wait, why do you keep saying that?
Because it's kind of important. Because to get an elevation angle, it's the angle between the horizontal plane and the line of sight measured in the vertical plane.
No, but why do you keep saying I have it at 7:31 and all this stuff?
Yeah, you don't have
41, so you can identify it.
It's in voice text.
41 minutes after the hour and live stream voice text under Quantum Eraser. I want to know, because you can't get an elevation angle. Anything you try to do without a horizontal plane is a law of identity violation if you're not including the horizontal plane. So my next question to you is, how do you have a horizontal plane on a sphere?
I think it would be useful to draw a diagram or something.
Draw a diagram? No, just tell me how you can have a horizontal plane on a sphere.
You cannot have.
Wait, isn't the latitude is the, like, if you forgot say a line going up to us, I mean, assuming a global Earth, the line going from the North Pole to the through the center of the Earth to the
why to assume? Let's have it.
What you're talking about doesn't have anything to do with a sail or looking at a horizon and measuring elevation angle. You have people standing on a sphere. What the? I mean, that's just not. Yeah, he doesn't even understand. He's still stuck on the sphere, like in this diagram.
You can't get an elevation angle off a sphere.
Exactly.
And not only to the stars, you can't get any elevation angles. None. Zero.
Oh.
They can't exist in your worldview.
Yep. So you
Simple
can't
as that.
triangulate on
Wait, can you define an elevation angle really quickly?
Holy shit.
Yes, for the third time, just with me. Elevation angle is the angle between the horizontal plane. You see, right at 41 minutes after the hour, horizontal plane and the line of sight measured in the vertical plane. So, as you can see, the line of sight in the vertical plane, that's the hypotenuse of the right angle triangle. The line of sight is not to the horizontal plane. That's already established in order for you to be able to get an elevation angle. You're screwed. With a right angle triangle, the whole sphere-tard collapses.
Yeah.
Yeah. How do you get the GP of a star if the Earth is curving?
He can't. He can't get an elevation angle.
So the horizontal plane, as you put it, is the plane that touches the sphere. Right?
No,
that's not a horizontal plane.
No, it's the one you're traveling along, bro.
It doesn't matter. He can't get an elevation angle. You guys are talking about the GP. He can't. They can't. The ball-tards have to dismiss a sextant from their worldview. It cannot exist.
I know. That's why they're in Cognis every time it's brought up. It's fantastic.
That horizontal baseline doesn't stop at the horizon. It keeps going and going and going to an observer that is zenith to a select object.
And when it's going, how that look like? Is it curving?
It doesn't matter. He can't get an elevation. You guys,
I know that
stop getting in on this. Just shut up. How do you get an elevation angle off a sphere? And if you can't, you're not on a sphere. That's it. End of argument. Unless you can redefine an elevation angle, you're going to have to redefine a triangle with that, by the way.
Well, I don't know. I think so. First, a few things. One, I'm scared to say anything because I feel like you seem to get respond poorly whenever I speak.
No reason to be scared.
No, I'm going to be honest with you. I don't understand. I'm trying to understand you, quantum eraser, what you mean. Like, could you perhaps, like, if you with assuming a circular model, could you? I think maybe the guy called Russ is trying to use a diagram to show what you're talking about. But I still don't understand when you say you can't get an elevation angle, because I'm just saying it's the line to the horizon.
I'm going to tell you why. Because I'm going to tell you why. Because it's a right. I got it right here at 45 minutes after the hour. You see this? This is a right angle triangle. Do you see that horizontal line at the base where from the adjacent? You see that horizontal line?
Yeah.
That can't exist on a sphere. Simple as that.
and that line, the horizontal line, what are you defining that as?
That's the adjacent to the right angle triangle.
No. But what, in terms of being on a globe, what?
You can't be on a globe.
You can't have X. You can't have X be a straight line on a globe.
That line's curved on a globe. You can't have it. You can't get the 90 degree beneath the. You can't get an elevation angle. Number one. Number two, you can't get the 90 degree the GP position underneath the star, because that's 90 degrees. You can't get 90 degrees on a sphere. No way.
And practically speaking, if you're traveling along that line, you would miss your islands up to hundreds of miles off. Sorry, you're lost at sea. Thank you very much.
Yeah, that's the next point.
But what I'm saying is that line is the tangent line touching the.
Okay, then I asked you, show me the tangent mirror.
And
that's not part of the definition. I didn't see tangent in the definition of an elevation angle. Did you?
I mean,
I didn't.
I don't know where you're getting this definition of an elevation angle from.
Elevation from radartutorial.eu. I got about 12 other ones. Do you need those too?
No, I'll just look it up. I'll see what you mean.
Radartutorial.eu. It's right there, and I pointed to it. The link's right there.
Live stream voice text.
Is he
Can
live?
I throw in on this for a second?
Please.
You can't measure an angle off the surface of a sphere because depending on where you measure it gives you a different angle. So look at this little triangle here. So the angle between Z and X, no matter where I measure it between these lines, it's the same value. But on a sphere, that is not the case. So you cannot measure an angle from the surface of a sphere in a line. Period. End of story.
Yes, so
Mathematical impossibility.
No, Indio, I agree with you that when you use a sextant, the actual, in time and space, the actual line that is the horizontal is different depending if you're in different latitudes. Like the diagram I posted shows that. You can see that the lines.
Holy crap! Water is still flat. Horizontal still. The line of sight is freaking horizontal.
Oh, hold on, Sonny. Let's say that one more time.
Me?
Yeah.
So if you see on the diagram I posted, right, you see where the guy's standing, the line that's at his feet in different spots. If he's is actually it's a different line. It's not the same line. So when you move to different latitudes, you can see that it's at a different angle, which is to say, they're pointed in different directions. You see what I mean? The lines at the people's feet aren't all. It's not the same direction. They're all different.
What? How do you get an elevation angle off a curved surface?
I'm going to look up what you mean by elevation angle just to make sure I understand exactly what you mean. So just let's talk about.
Right. So, but you think that under that horizontal line, there's actually a ball. So,
because the horizontal line is the tangent to the ball, so it
Yeah.
changes.
Okay. So I got to ask this question right now.
Cool.
Then,
Prove it.
are ships traveling along imaginary balls?
Wait a second.
I mean,
don't
along the
see-
surface of an imaginary
Wait a second.
ball.
That's not an elevation angle. I don't see a tangent anywhere. Any my definitions, none. Do you?
Oh yeah, these Okay, so that's just how the latitude is calculated using a sextant. If you look up the definition of elevation angle, I'm sure it probably does. I mean, I'm sure it does probably assume.
Sure, or probably.
I don't know because I know a lot about math. I mean, there's different things about like the definitions of elevation angle. I mean, I don't know where you got this definition. Let me look.
Radar tutorial. I got 3 at 49 minutes after the hour. Radartutorial.eu, byjust.com, and susdesign.com. All saying the same thing.
So that's what it is, and that's how it's used.
And what we get, John.
So I have to say, I really have to look this up because this is some terminology I think that is specific to what you're talking about, and so I need to.
Yeah, it's about traveling across a flat horizontal plane.
QE did not start those websites and put up those definitions. They're not our definitions. So if you go on, sometimes if you go on SunCalc, they'll call it an altitude, but that's in astronomy, right? Actually, that actually only applies to the sun. So wait, we're talking specifically about celestial navigation. So each of these little fields have their own little stupid terminologies. Celestial navigation, it's an elevation angle.
So yeah, I agree with you. Elevation angle assumes a flat ground from A to B. Using that diagram you did from O to B. Yeah, I get it. Yeah.
assume or using?
You don't have to.
Well, it's just. I mean, it's explicit in the diagram. It's just a horizontal line.
Yeah, you don't have to assume anymore.
We are asking, does we assuming when we use the sextant, or we are using the horizontal plane?
So you're right. It's using it. So 52 minutes after the hour, Jacoby Harold, professor of astronomy, Columbia University, navigation, chapter 6, the sextant, from Cornell University Library. The height of the sun or of any star in the sky is called its altitude. And so the altitude is always an angle to be measured in degrees or minutes. The point directly overhead is the zenith. The angle between the lines drawn to the horizon and the zenith is 90 degrees, or a right angle. Turn out the lights, baby.
Between the horizon and the zenith?
Turn out the lights, baby.
Wait, can you read that last sentence again?
Drawn to the horizon and zenith is 90 degrees.
I agree.
Yep. Turn out the lights, baby.
What does that mean?
Once again,
the sphere is dead.
On this use of the sextant and the right triangle.
Yeah. So
again.
The zenith, according to the spherical Earth model, is the line that's perpendicular to the surface of the sphere. So
what's zenith?
So that the zenith, as you know, you just mentioned the zenith.
Zenith at 90. Show a 90-degree angle on a sphere.
Oh, between the tangent to the sphere and the
no tangent. There wasn't any tangent in my definition. You made that up. You're not traveling a tangent. It's non sequitur.
Is it my English bad? I'm reading. The point directly overhead is the zenith, 90 degrees, and the line, it's horizontal line, and you get angle. What is so difficult to understand?
He gets
nothing. I don't think anything. I think we just agree with each other. Yeah, it's the zenith is perpendicular to the sphere.
And your zenith.
No. Can't get a 90 degree off a sphere. Do we want to go to AutoCAD next?
You can get a 90 degree from a.
No, you can't. Show. Pull up AutoCAD, or we can all watch it right here because I got it. You ready? It's only a minute and a half. You ready for it?
Yes.
Yeah. There you go. At 55 minutes after the hour, it's time stamped. 90 seconds. Say goodnight.
The Pink Panther. That's great.
So are you saying in this video is exactly what you're talking about summarized into one video?
Exactly.
All right. I'm gonna mute myself and I'll just watch this video. I think that'll help. So
90 seconds. Thank you. Pinky is off. Pinky's off deafen. Pinky.
Hi.
That was a long 90 seconds, man.
Oh no, yeah. I watched the whole video and then I was also.
Why would you watch the whole video?
Oh, I thought it was.
He was doing his due diligence.
Hey, Sir Edward, can you tell me if you can hear me? I'm just testing my Wi-Fi here.
Anyway, I posted a video about how to get
No,
because I'm gonna go. I have to go to dinner now.
90-degree angle off a curved surface.
See, I don't nothing. I don't think what I'm saying is about 90 degrees. If you want to know what I'm talking about,
question.
I don't know. It depending on what you define not by 90-degree angle.
I'm sorry, 90-degree right angle triangle off a sphere.
Yeah, we could go down this. I think if you just watch the video that I
I just did. This is in your video. This 90-degree angle.
Why are you yelling at anyone who doesn't understand you?
Hey.
So when you're trying to, there is no 90-degree when you're like say finding the.
This is from your video.
I know in the very beginning because he's standing at the.
No, it's in the middle actually.
Oh, where? What point?
That's at it's a 6-minute 14-second video, and that's at 4:20.
All right.
So 2/3 of the way. You didn't watch your own video, did you?
No, I did not because
Well, you watched the whole entire other video.
Because I already know how to use a sextant with a global model. But let me just look this up.
Well, you can't because that's a fucking non sequitur. That video in AutoCAD showed that he tried to get an angle from the hypotenuse to the adjacent. What happened?
That the video you posted, he was trying to find he's trying to draw a line from where he is on the sphere to the GP, as you call it.
He was not trying to draw a fucking line. He was trying to get an angle from the between the hypotenuse and the adjacent. What happened?
Yeah, but it doesn't work. Well, I mean, depending if you want to do calculus or not.
Thank you.
But I understand what he's talking about. Like, yeah, if it doesn't make sense.
Depending on whether you want to do calculus, get the fuck out of here.
You didn't actually listen to that, did you?
I did.
Okay, so he said, if I'm in AutoCAD and I hit the angle measurement and I pick 2 lines, it gives me an angle. But when I pick a line in an arc, it says in proper shape or something like that, right? And the reason is because every point on the line every point on the arc has a different value, different angle value between it and the line. So AutoCAD will not spit out an angle measurement off the surface of the sphere. So you didn't watch it. You didn't even watch your own video.
I did
You're
watch
scrambling around. Did you miss that part? The time?
No. I got the AutoCAD doesn't want you to try to find an angle with a curved line. I'm just saying that you can.
What is AutoCAD?
I don't think I need to answer that question. Can I just? And by the way, I looked up the point in the video.
No. What is AutoCAD? What does it do?
It's an engineering tool to build models in 3D graphics and try to
so to make things in the physical world, right?
Yeah. But anyway, so
it won't let you do it. Why? Because it's impossible, right?
Well, it's just not defined in that program. I mean, mathematically, what does it mean?
So show us. It doesn't mean anything because it's not possible in math. It's not possible. You're denying reality.
Yeah,
that's why we're getting irritated because you're denying reality.
No,
you're here. If there's a 90-degree angle, which there is, that means there's a right angle. If there's a right angle, then you can't have the surface of a sphere. Your own video shows a straight line in a 90-degree angle.
Yeah, so I can do the 90-degree thing. So I watched the video. I mean, I watched the bit you're talking about. So with that, he's talking about the zenith, which is perpendicular to the sphere, which is curved at a certain point. You can't have it 90 degrees above that. So that has to do with calculus. Like, you know how in calculus...
No, you can't.
It has nothing to do with calculus, dude.
Nothing to do with it.
Well, it does a lot. I mean, that's what the zenith is 90 degrees away from the tangent. That's at a curve. You can have the angle.
Where'd you get the tangent?
You can have an angle at a curve at a certain point. You can have a tangent line there, which is the.
Where'd you get the tangent from?
Well, that's 90 degrees away from the.
No. Where'd you get the tangent from? Did it come from the sextant?
In the sextant, it's model. It's the same thing as the line to the horizon.
Although wrong. That's not a tangent. That's a horizontal plane, and the definition of an elevation angle.
So a tangent against a 3D sphere.
No tangent.
Would be a plane.
Not a tangent. Sorry, you're making shit up. Citation,
that's conceptual. Please. So from your own video, I'm going to post it again.
Sure.
What is that? This is your video, your evidence.
Yes.
Yeah, what does that say? Horizon? So everything QE just said is factually correct, and everything you said is made up bullshit. Sorry.
Yeah, so in the video, so at the point...
So more made up bullshit. Hand wave what I just said. Pretend I didn't say it. Go ahead. Keep going.
No, I'm honestly trying to figure out what you mean. So the horizon would be the line that's tangent, or this in this diagram that at 420, or at least at 434, that's where I'm at in the video, in the one I posted.
Yeah, that's why he asked you for a citation for that, instead of made up bullshit.
Well, that is just what...
Yeah, that's your made up bullshit. We want the citation.
It says the horizon is a tangent. Please, the floor is yours.
But the line from you to the horizon
is a horizontal plane.
Yes, I agree.
Yeah, so that's not a tangent. And where'd you get the 90 degrees? The second question, where'd you get the 90 degrees on a sphere? Here we go again. It's just like Groundhog Day.
It's the perpendicular line directly perpendicular to the surface of the sphere that you're standing on.
Not to the sphere. You can't get a 90 degree. We just showed you in AutoCAD.
Okay, one second. Let me find some better ways to explain this really quickly.
You can't explain it.
Has anyone in this room taken calculus?
Do you know what a fucking right triangle is?
Yeah, yes. But
What's
can I
a
ask,
right
can
triangle?
I ask you guys this? Has anyone in this room taken calculus?
What's a right triangle? Fuck your calculus. You'd fail 3rd grade geometry.
That's a good point. I don't know how you're in calculus.
Define a triangle.
Wait, I'm just looking something up, but I don't think I need to.
You better look up what a fucking triangle is. I don't even know why I'm going down here. It's all over.
Yeah, it was over.
Yeah, it's over. Don't worry about it. You're done.
He's swimming up the stream of lava at this point.
All right. Well, anyway, sorry if you guys are getting mad. I wasn't trying to annoy you guys at all. I was just, trying to figure out what you were talking about.
We're just getting frustrated.
You know exactly what we're talking about. We're getting irritated by your dishonesty. You know what we're saying is correct. Your own source said it was correct. But because it comes from flat earthers, it's a bunch of bullshit. And now you're even throwing your own source under the bus.
Oh, and by the way, in your little diagram here, the sextant's not measuring the zenith above your fucking head. So I don't know what he's doing.
Which one? Which diagram?
The one that Indio posted from your video 22 minutes after the hour?
Oh, yeah. So that is measuring straight up from the guy's head, right?
Yeah, the sextant doesn't measure straight. The sextant doesn't have a fucking plumb bob on it.
No, yeah, you're right about that. The sextant doesn't do that. The sextant measures the to the horizon. Although actually, if you think about it, you could measure to the zenith and then to the object in question, and
zenith
then
of what?
The zenith using a plumb ball. You could use the zenith and then measure the to the object in question, and then just subtract 90 degrees from it.
Yeah, that's the co-altitude. That's regardless of that. You don't have a plumb bob on a sextant, and that's not what a sextant does.
And even if you did, horizontal is defined. The horizontal line is defined as 90 degrees from the plumb, from the perpendicular.
Yep.
So you still got a 90-degree angle. You're still screwed.
Yep.
You honestly could have a one with a plumb ball on it. That would actually work, and then you wouldn't have to use it.
Look, check this out. I haven't got anybody to read this out today. Can you go on and read where it says figure 2?
Where at?
In the live stream voice text. Because he keeps saying he doesn't know what you or Indio are saying. And
okay, I'll read it. Figure 2. The angle measured with the sextant is in reality one corner of a right triangle formed by you, the celestial body, in its geographical position on the earth. It's all over. Right triangle. It's done for. They even got a picture of it. Of course, they got it on a sphere, but it goes underneath the water.
Yellow water triangle.
That's pretty good.
Yeah. Well, shit happens.
are you really going to be quiet now? The moment you're going to decide to be quiet? Do you understand, or?
No, I'm just reading the thing.
He just read it out.
I'm just looking up the. I think that's to do with more like not if you're using Polaris. You're using there's other things you can use the sextant for, like the geographical position against things.
Can I ask you a question? Does it say tangent anywhere in there?
Probably not.
Probably not. So why are you saying it? I can
I just
search.
know the definition from that.
Yeah, great. But I can go search gazillions of celestial navigation manuals, and I'm not going to come across the word tangent.
No, they I don't think they'd be in there. I agree.
Yeah, but can you honestly search? Can you do it honestly? Right?
Doesn't matter anyway. He's not going to find it.
Because honestly, right?
Wait,
Honestly.
he just agreed. So you agree that you're not going to find it. So what's your...
Yeah.
Oh, I mean, you might. I don't know. It depends.
You ain't going to find it. It's not there.
Maybe if you wrote the navigation manual.
Well, sir, you gotta consider, if you're gonna be honest about this, you're gonna be debunking the globe. Are you ready for that?
Calculus is used to calculate certain things, man. Not a ball, not a basketball. We don't need calculus for basketballs. We know radius.
Yeah, it's simple geometry. It's all over.
Yeah. So stop trying to use calculus to say that curved lines can be straight lines, because that's retarded. Honestly, honestly.
Yeah,
because if I say honestly, then it's true, right?
I don't believe you. I don't agree.
All right, this is the only point that you
One
guys
second, let me just
going
look it up.
over?
I'll be back. One second.
Oh my God, this dude.
You're gonna look what up?
These guys don't believe.
Say,
Hey, I'll post the definition for honestly for you. Okay.
These guys.
On you, Elijah. Go ahead.
Yeah, I'm just saying, like, these guys don't believe in a sphere. They don't believe in a geometric horizon. And now you're gonna go ahead and how are you gonna justify denying what you see right here, a right angle, and them trying to say that there's a bit of a curve on that water there? Like, that's obviously ridiculous.
Yep.
Like, why can't you just respond to what's obvious? You don't need to be like a Preston University student or something. Figure that out.
Because you will not get me. I don't want to be flat earther.
So, what else have you guys gone over with him? Just this argument? Is that it?
Well, we tried with the radius, but nothing. It was more about satellites in the beginning.
Oh, satellites. We can bring that. Okay, let's get back. Well, when he comes off Deathin, we'll hit him up with the satellites. I want to hear his how he's going to deny the second law of thermodynamics. So we'll get a list. Denying right triangles, denying second law of thermodynamics. We'll just make a list.
All right. So I looked up the using a sextant in the way you're describing with like things like the sun or other stuff. So yeah, I understand that in that case, what the diagram you posted is correct. So it's everything's good there.
Right. So your mind should be red flags should be popping up because that's obviously a contradiction of what you believe.
No, it's not, because what I'm talking about is using a sextant to find.
Don't say no, it's not, and then reply with a non sequitur.
Oh, I'm definitely not going to.
As it pertains to you taking an elevation angle measurement, right? That would be done in reality, right? So if we're doing that in reality and there happens to be a star, whatever distance away, you know that you're angling that sextant to be horizontal and measuring a vertical position of whatever star that is. Now, there's going to be a ground position. And you understand that there can't be any curvature between you and that position. That's just what it is. So you can't tell me that that's not a contradiction in what you believe, because that makes no sense.
But by the way, that diagram you posted isn't how you use a sextant, because obviously you don't know where that GP is. You do measure it from the horizon, and then what you do is you do a site reduction calculation to find out where that GP is, essentially.
No.
Oh my God.
What does that have to do with that? That's why. No, stop. How did you get the elevation angle to begin with?
You measure it from the horizon, surely.
You measure it from a horizontal plane. So we're going to go back over this. Show me a horizontal plane on a sphere.
That's
every turn you make, there's a flamethrower there. Have you figured that out yet?
So I'd like to see the full this thing you posted, the full where it says figure 2. Like, is there any more to this? Because I feel like
why it's not
I
going to
want to see
help
more
you.
of this.
It's not going to help you.
Well, I just like to see the full
You're going
context.
to have to redefine an elevation angle.
I just like to, if
And a
anyone
right
knows where
angle.
to post that.
And the zenith. And 90 degrees. And like you have to rewrite geometry, bro.
Yeah.
Is seeing more of this going to change the fact that there's a right angle formed between you, the celestial body, and the GP? Is that going to change, you think?
I'm sorry, I'm just reading the thing.
No, you should be reading what I cited. You got to stay focused. See, I told you there was the circle bit to the left. So I'm asking you, if you had
Don't ask me. I'm
more,
just going to read
so
the thing with figure
if you
2.
had more information, would that change what figure 2 says?
Possibly. One second. Let me just read this thing at its entirety to make sure it doesn't, because this thing says it's contradicting into Wikipedia. But like, let's see if it
contradicting Wikipedia. Oh my God! Hell no!
Ooh, damn. Is that your problem? Is that your problem right now? Is that why you can't process the information? Because
Delete
Wikipedia?
this shit. Delete that. Scrub that from the internet. It's contradicting.
You know you can. You know you can correct Wikipedia, right? Just go correct it then. Fine to find that out. You know, but what? I know, right? More accurate than Google Maps.
Well, especially, I don't know if I know
the story that the stars.
There you go.
What's that?
Yeah, what's up, man? What have you got?
So yeah, I was just looking up all about this, like, geographical position, line of sight, intercept method, all this stuff. It's really interesting. Yeah, I learned. This is why I like Discord, because I didn't really know about all this stuff before. But yeah, it's really interesting. I mean, the thing that figure 2 you posted, I'd have to see more of the of what it's talking about to understand what it means, because that's certainly not. I mean, what
you need more graphics. I got you, bro.
just where you got that from.
No, it's okay.
Elijah,
look, it doesn't matter. It doesn't matter where. It doesn't matter where you look.
Well, could you send it to me, just because I'd like to see if that's in more context makes sense?
Are you questioning that?
No.
Are you questioning that that's what it is?
No, he wants to read the whole thing. He wants to link to the source.
Yeah, if you just give me a link to the source, because what that figure 2 says doesn't really make sense, but maybe it will make sense with more context. But
and why doesn't it make sense? What do you mean? What about it doesn't make sense?
Because that's not what a sextant is measuring. You can do calculations to get that horizontal line.
What do you mean? What do you mean a sextant isn't measuring what?
The distance.
What isn't it measuring?
It's not the angle you're measuring is not a right triangle between you, the GP, and your boat.
Oh, you think so?
No, but you can find
That's how I feel, Sasha.
So hold up. So let's just explain some things. There are these almanacs. Okay, they're called almanacs. It's where everyone thinks, where the navigators, where the people who study the stars, is where we know the stars are going to be, constellations, the sun and the moon, in the sky. These, if you're going to go navigating, you have to have these almanacs, either in book form or in software form. You need this data in order for you to look up and know what you should expect to see in the sky. Now, you see the sun, you see the moon, you see the constellations. Check the almanac. What do you see? When should you see it? Where am I? Now, you use a sextant. Okay, you use a sextant to find the positions of these things in the sky, and you match it with the almanac. And then you can figure out where you are. Okay? Do you understand how navigation works?
Yeah.
That's how this works. You can't get these angles, okay, if you think the ground or the ocean is curving. Do you understand that?
No, that's not true. In fact,
You don't understand that. So you don't understand. You didn't learn that in school. Is that it? You think something totally different from what's taught in school about triangles. What is it? How many degrees does a triangle have?
Well, anyway, okay. I think I'm gonna go now, but
Well, think about it. I think there are 80 degrees. Okay. Now, if the ground is curving, how many degrees are you going to end up with?
Oh, it's not really like that. You find so I understand that the angle between the object and the GP, as you put it in this diagram, figure 2, and the angle between the line to the object and to the horizon are different. That's that's why you have to do that corrective method to try to figure out the circle around the GP in which you could be located. But there's
Yeah, well, you do a couple of them. You have to triangulate. You don't just do one. You take a bunch of readings and you triangulate where you are, where you think you are.
Yeah.
But how are you going to do all that? How do you calculate?
Before I go, I just want to say if you get struggle with the whole how are you going to find the horizontal line at the bottom bit, don't even worry about that. Don't focus on that. What you can do is you can find the angle between the object and the zenith, which is just directly above your head, and you can figure that out using
how you do it.
That's
bullshit.
No, wait 1 second. Using a plum.
I'm not waiting anymore. Fuck off.
And then the last thing I'll say before
fuck off.
Hey, it's Speculation Sunday.
Just go.
Why is he lying, man?
Listen, he's just making shit up at this point. Like he already did with the tangent line. Like he just goes back. He's like, maybe they won't see it this time.
Trying so hard, right? Calculate that. No.
He tried to bullshit with calculus. Like he was like, you just have to use calculus. I love when they say that. They have no idea what calculus is. They're hoping, please don't know what calculus is. They're flat earthers. There's no way they know.
Hey, Bong, to answer your question, when you have a curved triangle, you have more than 180 degrees.
Well, it depends if it's convexing or concaving, right? Into this.
That's not a triangle then.
I know. It's
exactly.
But if you calculate,
it's a circangle.
Yeah, everybody's blood boiling.
It's a circangle.
It's a triangle that had the surgery and reassigned.
The transangle.
Oh my!
Right. So much fun.
You can't say you didn't let him talk because you let him waffle for at least a good minute before you finally said, no, we're not going to do it. He wouldn't make his point.
It's the idea that, yep.
Well, I was just going to say, he started bring your own celestial navigation. So sometimes they have the bring your own globe where they try to just bring their own version of the globe model. And this guy was trying to bring his own celestial navigation at the end there.
Bring your own model.
It's like what you were saying, Bong. If you use 2 stars there, right? So if you're at one of these intersecting points of this line of position, the 90 degrees is where the star is at, man. Not where you're not. There's nothing above you. I don't.
Yeah.
Why did they just? I don't. You cited something already, bro. You had your chance, and then you totally dumped on the video that you posted. So I mean, I don't get it.
You cited the wrong video.
What's up with it?
Why doesn't? So it's Speculation Sunday. Does India want to take them off moot? And...
No. Oh, come on. No. I mean, as long as he, caveats it saying, I'm speculating now. This is how it could be done in my mental construct.
Yeah.
You think he would?
Think he would what?
I'll unmute him.
Admit the truth and say that he's just speculating and imagining?
No.
Just take odds. We need to have like some sort of
Is this Vegas?
tokens or something so we can bet on stuff.
Some tokens.
Like we could bet on like what their answers will be, or like it would be funny.
I totally gamble.
All in, he says Eratosthenes.
Oh, bingo. We play bingo.
Bruh. All right, I'll mute the guy. I got a question for him. My question is, do you know what a trans angle is?
Oh, God.
Oh, do I want to go there? It is Pride Month, so I will unmute him.
It's
Math is done. Math is over.
It is something that is not a triangle, but you can believe it's triangle. Therefore, it's a trans angle.
It's a trans angle.
So anyway, I'm not going to argue anymore. In fact, I'll be quiet for quite a long time. I just want to say thank you for talking to me about everything, and hopefully, as far as all these pro-global people go, I wasn't too bad. Maybe I was.
You're all right, man. Like it's hard to let go, man. Like it's like Santa Claus. It's hard to let go of Santa. Like,
yeah, and the only thing I'm guilty of is being stupid. If you're right about this whole flat Earth thing, so so as long as we talk to each other with
well, no, it's not stupid. Like it's
ignorance.
They get you when you're young, man. But that's it. Like I always say this, when you went to school, when you went to kindergarten, and you went in the room, and they said the Earth is a ball, they didn't actually give you any evidence for that claim. And what they did was they showed you that if you thought opposite of that, you were going to be ridiculed and shamed and all this other stuff, right? They didn't use the traditional techniques of so-called education, right? They said only stupid people thought the Earth was flat, and they thought you'd sail off the edge and, sea monsters and blah, 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 right? They didn't say, oh, so here's the measurements of curvature and this, that, and the other thing, right? They didn't teach you any of that. They said, see the toy in the corner? You live on that. Shut up.
Next subject.
Tell me I'm lying, dude. Tell me I'm lying. Tell me any of that's inaccurate.
No, yeah, they certainly didn't prove it.
They didn't even give you evidence.
No. And even if you ask how gravity works, the teacher will be like, I don't know, it just does. Or they'll let you play with magnets and tell you that's how gravity works.
Well, anyway, I've got to go, but nice to talk to you guys. Hopefully you'll do it another time.
Yep. Later.
We're about to talk about it.
I know a lot about space, or not that much, but a certain amount about space travel and stuff, so I could possibly help.
How can you know a significant amount about somewhere where you've never been and don't have any experiments to prove that these things that you believe in are real?
Well, I guess from my point of view, there's lots of evidence that it's real, and I don't know anything about. Yeah, I mean,
and what is that?
I don't know. Like, for instance, I've never been to Saturn, but we can figure out what's in its atmosphere.
That's the evidence.
No, you can't. No, you can't.
The evidence you're talking about is what we're about to talk about too. It's the photos, it's the the video.
So it's lore, and it's like knowing a lot about Star Trek.
Yeah.
I thought he was going to say something like, I know a lot of, I don't know a lot about Saturn, but I heard the weather's nice over there. Like, that's what it sounded like he was going to say.
Hey, I'm still waiting to go fishing.
I got my hand up
on the moons of Venus. Europa. See.
Well, I mean,
Timbo, I got my hand up.
I don't know what conversation he was having prior to this one, but it sounds like whoever it was probably didn't have any evidence for the Earth being a globe, other than if he did, and he would have provided it, and the person would have been like, "Oh, okay, that's evidence right there." So obviously he didn't have evidence, and neither does he have now. So he doesn't want to get into the non-evidence of the case.
The only real evidence of such things, right, is observable evidence. Your mind naturally says, "Oh man, there's got to be so many videos and footage, right, of a rocket leaving the Earth, and we see the ball." There are none. There are zero.
The question is faith evidence, and further to that,
so there's no evidence.
Is faith evidence, and further to that,
How can I get more faith in the ball?
I feel like we're never going to know because Pinky's never chiming in. We're just talking amongst ourselves. So we probably would just go to the next guy and we'll talk about it other than Pinky. So
Yeah,
Pinky would have to then come in now.
Someone else, yeah. I mean, honestly, it's like I'm just a little bit tired at this point. I don't really want to.
Tired of what? Yeah, but that's the issue though. Like we don't know what you're tired of. It's like you're just telling us you're tired. Tired of what? Tired of being right? Tired of being wrong? Like what? We don't know.
Provide
like,
at least
kind of tell us something.
At least provide one evidence, like at least the strongest that you feel is the strongest evidence. At least do that, like photos or video. What is it?
I'm a roast. Base me.
Because it has to be photos or videos, right? Like your brain doesn't naturally freaking start looking up at stars and try to do all this stupid math that these so-called astrophysicists.
Yeah, but I think we're just kind of like elaborating, Bong. I think we should just let Pinky. I mean, the floor is yours. Tell us what's going on.
Yep.
How about instead of giving you specific evidence, which I could. I mean, I think there's a Wikipedia page, empirical evidence for spherical shape of Earth. You've probably all gone through all of that and stuff. I guess for me, I could.
You can't get away with that shit.
You're using words wrong. Okay, it's not empirical evidence. Did you hear QE explain what empirical means earlier?
That's just the title of the article. I don't know.
What does empirical mean? What does the word empirical mean?
For me, it just seems like overall, if you look at, I mean, I guess it's more of just.
What is the definition of the word? I'm not asking you for your opinion. I'm asking you for the definition of the word empirical.
I guess it's basically if.
No, it's not. I guess.
In the world.
Just look it up,
listen,
man.
Listen. I'm not giving you a specific argument. I'm just saying if you actually want to know why there's so many globe Earthers out there, it's because if there's so many people.
We know why. Why.
It's basically if all these independent people, scientists, governments.
It's not independent people. No, that's false.
If they've all come with this conclusion, and there's lots of different ways apparently of them proving it.
But you're making false statements.
Satellite images.
You're assuming that you're making false statements.
People have gone to the South Pole. People have gone to the North Pole. All this, like basically, all
people
totality
have gone to the South Pole.
Wait.
So the claim is
wait. Before you guys attack each thing I say, can I just finish my the reason?
We just got to go through the claim. The claim is
go through them one by one.
The claim is that, hang on. The claim is that there's a ball rotating in a vacuum of space. So first of all, everyone says, "Oh, they discovered this 2,000 years ago." How did they do that? Because don't worry about satellites, because you need a ball for a satellite.
Indoctrination. That's how they did it.
Well, I mean, I haven't looked it up, so I'm like a standard, globe believer, so I don't really know the exact details. But I think if I remember correctly, wasn't there something like maybe finding the radius of Earth using a solar eclipse somehow? From
yeah, see what you're doing right now is what all of them do. This is what every glober does. Not one of them knows how this knowledge was derived because it's not actually really knowledge. It's not an actual conclusion that was drawn. It's a pre-conclusion that was worked backwards from.
Right, but so just if I could really quickly, before we go down each and everything, to finish what I was talking about in terms of looking at the whole picture, it just seems to me that it's far if if all the people in the majority have agreed on this one thing, and different people, like different countries that can even compete against each other.
Pinky,
and there's all relevance. Wait, listen.
Spare us the motive speech. No, Pinky, spare us the motive speech, dude. Spare us the motive. Spare us the motive speech, dude. Well, if everybody was in on it, dude, let's just skip that and go straight to the evidence. That's what we want to talk about. We don't want to talk about why psychopaths do what they do, bro. Like, let's just drop that whole why would they do that shit.
No, but
we're not gonna talk about that. Let's just Bro, let's get into the evidence.
Okay, but you've asked for evidence, and this is the one I want to talk about.
Because Pinky, it's not evidence. It's not motive, brother.
Wait, listen.
It's not the motive of what. Listen,
Pink. Yeah,
sure.
Ladder, just please, whoever's jumping in here besides me, please. So what we're doing right now is ascertaining the information for what evidence there is for the claim of the Earth being a globe. We don't care to hear about the motive of why psychopaths do what they do. We don't care at all. Period. Zero. We don't want to hear it. I don't care if maybe somebody that you know, a friend of yours, has the information. We just care of the evidence. That's all we care, Pinky. So the next words that you should be talking about are the ones that are going to be pointing us to the evidence that you have. That's all. So let's just start there.
Right.
Nice
Okay.
and calm.
We can do that, but
No, we will do that. We will do that.
but
No more diatribes. No more diatribes. No more soliloquies.
This is
Bring
what
evidence.
okay, listen. See, this is why I didn't want to talk about it. This
Pinky,
is,
I can
this
help
is
you
the
real
evidence
quick.
I want to bring to this, right?
I can help you real quick. It's not evidence, right? It's a geometric claim, and you're making a social argument. That's the problem, right? So start
I
making
know.
a geometric claim.
Yes,
argument.
I know. It's not concrete, but this is still, in fact, evidence. If you don't know this, so just listen to this, right? There's so many, like all these things that you're doing, which is like, if I bring up a certain thing, you'll say, "Oh, well."
Now,
it could
you're
be
talking about me now. You're talking about us. That's not a geometric argument.
I'm not talking about you specifically. I'm just saying flat Earth is what they'll do.
Okay,
There's a certain amount of study that you guys.
A group of people, that's not a geometric argument.
My God.
There's a certain amount of study
Flat
into all this stuff.
Are you seriously doing this, Pinky? Are you divining people's thoughts now? Divining their thoughts? Well, if I was to give you the evidence, it's just like you wouldn't hear it. Just tell us the goddamn evidence, bro. Stop playing footsies with us under the table, bro. Just tell us the goddamn evidence, so we can get on with it.
Okay.
You're waffling, bro.
No, all right. Listen, let's say this. So I think I'll just talk some other time because this is what I want to talk about. But this is, yeah. So I think I'll just probably leave it.
Relax, okay, you have no evidence to talk about. You want to talk about other things instead. Okay, noted.
No, I'm talking about it, especially since the way you're reacting. I can tell this is something you haven't considered.
You're making a social argument.
We just want you to join the conversation.
What's his evidence? Did you say it yet?
You're jumping through freaking hoops just to tell us evidence, bro. Like it's motive, then it's divining people's thoughts. Now it's like, well, my feelings are hurt now, so I think I'm about to excuse myself. Dude, is this what you're talking about with evidence? Like, why don't you just get down to it? Just get right down to the evidence. Tell us what it is, and we'll talk about it. And don't get all like your feelings are hurt now.
All right. Listen,
stage left, bro.
What I want to talk about is a statistical argument and also an argument from
the fuck?
That's not geometry, dude.
We're talking about the freaking shape of the Earth. Like the man said, geometry. Why can't we start there? It is a geometric shape, is it not?
Because this argument that I'm talking about.
Is it a geometric shape?
Yes, it is, but this is one of the more important ones, which I feel like a lot of you guys don't seem to grasp.
What's statistical argument, bro? What's your statistics? What is it?
No, what the fuck?
Okay.
What? No, fuck some statistics, dude. We need some geometry. No. Fuck some geometry. Fuck some statistics, dude. We need some geometry right fucking now. Now, fuck the statistics. I don't give a fuck about who said what. Bring some fucking geometry right now. Where's that shit? Because that's what we're concerned about. Fuck statistics. I don't give a fuck how many people thought about what, who, where, when, why. Give us some goddamn geometry right fucking now. Like, that's what we need right now. That's all we need. Geometry. Geometry. Sphere, radius, diameter, circumference. Let's have it. Go ahead. Whenever you're ready, present geometry.
I'm sorry, I don't want to talk about that.
Thank you.
Pinky, I gotta be honest. I think it's weird that you're scared of like geometric claims.
It's the sphere. We're talking about a
I'm definitely not scared of it. I just.
Well, then just tell us.
I just think something else is more important. I mean, I'd rather talk about something else.
Something else is more important than the geometry of the Earth that we're standing on. Is something else more important? That is the actual claim that we're talking about. We're getting down to the claim of geometry. And you're telling me there's other things that are important to provide evidence instead of geometry? Drop over distance? What could it be?
Well, listen, if you guys ever want to talk about that, I'm happy to do it. I don't know.
What?
I'm not going to get bullied into talking about something.
No, we don't care. We don't care how Group A likes ice cream and Group B says that they don't like flat Earth. I don't give a shit about that. I give a care about like what people are saying about the geometry of Earth. In that, the people who think the Earth is a globe, they think it has a radius, diameter, and circumference. So how do we know that's the truth, Pinky? Because that's the only thing that we're concerned about. Not about stupid statistics. No one cares about that except for you and every other globe earther who wants to talk about every other derivative topic under the sun except for geometry. Right?
Yeah, because this would answer the whole question. This would be the first question that you need to answer, right? So.
Yo, Winston gets it. What's up, bro? I share your videos all the time, bro.
Hey.
It's kind of too much for him most of the time.
Appreciate the shout out, my good sir. But we're getting to the bottom of why Pinky's not giving us that geometric shape.
Yeah, let's focus here. Focus.
Pinky's chilling. He's trolling. He either knows or.
I don't give a fuck. Let's not divine his thoughts. Let him answer the question, guys. Whoever's answering right, let Pinky stand up on his own 10 toes and tell us. Go ahead, Pinky. That was your cue.
Look, if your statistics have to do with measurement, uncertainty, or precision, yeah, then it would be valid. But
no, this is just in general, like smart.
Hold on.
How to see further in certain situations, which I think is going to be far more useful than going through different things.
Fuck me, dude.
The statistics
anyway,
are based
I'll do it.
No, the statistics are based upon what? A Gaussian probability or Lorentzian p-values? Like what?
Bayesian. But anyway, I'll see you guys.
A Bayesian inference.
What is the likeliness the government will lie?
Hold on, man. Fucker derailers, dude. Based upon what data set?
Just there's no single data set. It's just all the different evidence you see in life, and
so no data anecdotes.
No, just. I mean, I could explain it, but I feel like
no, you don't actually have anything to explain because I just asked you what data set and you don't have any data.
All right, so I joined this server trying to explain stuff.
Yeah, so now you're going to talk about us.
Now I try to explain it.
No.
You don't let me explain it, and then now you want to ask me questions about it.
So can you derive Bayesian inferences without data? From which to draw
I'm going to come back when there's a list.
Yeah. When you actually have evidence.
Oh, not only do I have evidence, I'm very
So where's the data? So where's the data?
No, I'm talking.
Wait, let me look.
Yeah,
where's hold his hand?
Yeah, bye.
They picked in space.
Wow. I think it's inside the sun. So the sun, the entire solar system orbits around a center of mass, I guess you'd say, and then so the sun is kind of orbiting around that.
But it's not in the center of the sun, though. Like the sun is supposedly moving around it and wobbling.
Oh, so the sun is a planet now, right?
I mean, I very clearly laid out that most ballers don't know this, right? So, like...
So they've got all these different layers of wobbles going on to explain, like, all these different things in the sky. Like, they would need one for the sun, right? And so there must be all these other things, too, that they need more wobbles for, right?
Layers of wobbles?
It's like changes in the stars and changes in the position of the sun over time, and then another change of position of the sun over time. So it's like the stars slightly move in a cycle over time, and so it didn't match their predictions for the Earth tilted and spinning and moving around the sun. So they just added a wobble and said you can't really measure it.
It just seems like they did everything but follow Occam's razor. They did the opposite of it.
They started with their conclusion, the globe.
Absolutely, yes. That's the main claim that will, lead. It's the first rung of the ladder, the cosmic ladder. You have to have a globe Earth first, then assume that Venus is the same size as the Earth, or relatively the same size. And then you go from there. These are the rungs of the cosmic ladder that they use. Even astrophysicists don't know this. They just assume that it's been done and they go off of that.
Yeah, like it's weird, right? Because their math didn't work. So what they did was they said, oh, well, like say a moon is moving around a planet and it's moving around the sun or whatever. Like they say, oh, they did the math, it didn't work. So they had to move the center a little off center of the planet. You know what I'm saying? So they're like, oh, well, it all moves around this area inside the planet that's not quite in the center of the planet to make the math work. And they call that the barycenter. It's like the balance point of all these objects supposedly moving around each other. It's just a mathematical fix. Dude, like no baller knows any of this either, dude. That's what I'm saying. It's really funny.
Well, we're used to the people that come in here to defend their government-fed education for whatever weird reason they feel like they have to defend it. Like, if you're going to come in here, you can just at least like hear people out and not refute, or I don't know, whatever mental block that people have to open up that barrier and just listen to the empirical evidence that we have to offer, because what we do have to offer is empirical, and then just obliterating everything that goes with the whole globe paradigm. Because once you debunk that the earth is not a globe, all of the other stuff has to go away, because like I said, the earth being its set dimensions is the first rung of the cosmic ladder of everything else.
All right, so let me
maybe
good.
Maybe they're just fighting with reality. You know, they come in here fighting with us, but you know, they're just arguing that they have a good reason not to believe reality.
Maybe I'll cover this tomorrow night, actually, but like just so you guys know fast. So there's like the precession wobble. There's like something that's called like nutation, and then there's the Chandler wobble. And then they say that the precession is like 25,000 years or something.
Oh damn!
I wish you could put some visuals to it, because I kind of don't understand it.
Yeah, what's the observed phenomenon again?
Right.
Sorry.
Like how the constellations, there's like a 26,000 year cycle for them to do like a full circle in the sky, right?
Yeah, it's about the position of the stars relative to the equinox solstices.
Right.
Yep, and that's like a quote unquote like 25 or 26,000 year cycle, and that's called the axial precession. It's like a wobble.
Right, so it's based on the position of those constellations at noon on the equinoxes and solstices, right?
Yes.
Yeah.
And they're saying that it's the Earth's axis undergoing like a slow wobbling motion, which is a cool story, bro.
They draw a path on their model, and then they say, "Yeah, 26,000 years to go and travel this path." Is that how they do it?
So the Earth
They have
is
a
spinning.
pre-conclusion about the Earth being a globe, and they see something in the sky, and they go, "What would need to be happening for that to happen, and the Earth to be a globe?"
So wait a second. You're telling me the Earth is spinning? It's going around the sun, and it's chasing the sun, and it's wobbling now.
Oh, it's wobbling in like 3 different ways.
And it's working. Yeah,
In 3 different ways. Holy shit!
Yeah, dude, we're just getting to the first one there. Like, so you look at the position of the stars relative to the equinox and solstices. They say that the Earth is undergoing like a slow wobble over a cycle of like approximately like 25,000 years or something. And then you have what they call nutation, I think, like nutation. And yeah, this is like because the path of the moon didn't match their predictions, right? Like there's there are like irregularities in the moon's trajectory. So they say that it's because of like the Earth, like the Earth's axis undergoing like deviations.
Stretching.
Oh boy. Yeah, this is kind of the same thing they say about like how they can't directly use the heliocentric model to predict eclipses. They say that there's just all these different tilts and wobbles going on, and you just cannot use those mathematics to come up with the correct answer.
It's so funny too, because like they say they both are taking place. They claim that like the nutation is just like superimposed on the other precession.
Can you spell nutation?
Nutation.
Okay. It's like, is this a song? Is this a joke? Okay.
Like, bro, think about that. They're like, okay, our model doesn't work. Well, actually, what's happening is the Earth is wobbling slowly over 26,000 years. and then like, oh man, our model still doesn't work because the moon's not doing what it's supposed to do. Well, actually, at the same time that it's wobbling over 26,000 years, it's doing this other little wobble that's superimposed. It's just doing both wobbles, but it's just doing it like every 20 years or something.
Wobble, wobble.
Look how far how long it is.
Wobble, wobble.
This can't be real.
18.6 years. So, precession is the slow top-like wobbling of the spinning Earth with a period of about 25,772 years. Nutation, in Latin meaning to nod, superimposes a small oscillation with a period of 18.6 years and on an amplitude of 9.2 seconds of arc upon this great slow movement. So that was pretty accurate.
Don't they use some star charts or something from like 10,000 years ago or something? Like it's like rock paintings or something to validate that. Isn't that to do with
something like that?
Also, why they say that Polaris won't be the center star anymore? One day it'll change.
Yeah.
Oh, but you do realize that all of these things like axial precession and stuff have to be taken into account by the geocentric model as well.
No, they don't.
Well, I mean, it's something that's going on. I mean, the thing is that this axial precession was actually discovered in the Hellenistic world when they actually believed in the geocentric model, but they explained it as like being in terms of the heavens moving, in a way such that the seasons are changing.
Well, that's what happens. We actually observe that the heavens move a certain way. That's what we actually observe.
The geocentric model is still a ball. It's just the Earth at the center and everything revolving around it. Ptolemy.
Yeah, that is one model. There were several Greek guys that came up with different models. There was flat Earth models as well from those Greek philosophers. That always gets ignored.
Which of course,
Thalius,
it can be, if you get a gyroscope from any toy store, you can put it on your desk and you can see the axial precession. So it seems like that's a far more simple explanation that if the Earth is spinning, it's just sort of doing that.
Well, how do you see the axial precession?
Wait, time out. How is it? What are you talking about? Your model claims that there's an axial precession, that there's nutation, and that there's a Chandler wobble. That there's 3 imposed wobbles. They're superimposed. So can you please explain to me how that works?
Why would you think they'd be mutually
exclusive?
What? Can't you have multiple things going on?
Wait. How can an Earth be spinning and then somehow have 3 superimposed wobbles?
Well, I mean, I guess do you want me to explain each one? Like what axial?
I want you to explain the physics of that. I want you to tell me how that's physically possible, that you can have an Earth tilted, wobbling 3 different ways at the same time.
But why is there's 3 at the same time of particular importance?
That's not physically possible.
You think that's impossible? Because we can go through them each one by one, and then I guess just look it up. But like, it seems like you have some problem with there being 3 at the same time.
Yeah, that's my question. So instead of us avoiding the question and pretend you're going to
I'm trying to understand so why do you think there can't be 3 at the same time?
I don't even know how that could be physically possible. So if you're
there's not even one
to explain it. No, why can't you explain it? Because it can't be doing multiple different contradictory wobbles at the same time.
But why?
Because that defies physics.
Can you tell me why?
You ever heard of Occam's razor?
Move in contradictory ways at the same time, buddy.
I mean, why are they contradicting to each other?
Well, that's what I'm asking you to explain how they're not. Because they're supposedly moving at different rates at the same time. So how can you have 3 different rates? You have a cycle of 26,000 years, and then a cycle of 18.6 years, and then a cycle of just like a year and a half. How's that work?
Well, I mean, so I understand the axial progression one. I'd never heard of notation before, but I could probably look it up and probably explain it to you.
Well, so as of now, you just believe it? Wait. So as of now, you just blindly believe it?
Understanding stuff, so I could explain.
No, but as of now, you just blindly believe it.
No. I mean, I understand what you're saying. It could not be the case, but I'm not talking about believing it or
You
not.
don't have to argue your point because your argument is with the curvature of the Earth. You don't have any right to talk about this right now unless you got
Guys, let Quintet talk with him.
Wait up. So, do you believe that that's what's happening?
Do I believe that that's what's happening? Well, yeah, all my beliefs are sort of on a scale of probability. So basically, if this is what seems to be going on, and I see a lot of evidence for it by NASA and different site implementations, then yeah, I guess I would have a certain amount of belief in it.
But you haven't done any of that because you currently are unaware of them. But you believe it's happening, so that would mean it's a blind belief, right?
No, it's based on, like I said, you know how I said there's a scale of probability, right? If it seems like this is something that physicists around the world have decided on.
Oh my god!
Wow.
Wait. I'm not saying it's 100% true. I'm just saying that seems to be more likely than not. I mean,
so it's a blind belief. You literally just admitted it's a blind belief. You said if it's something that physicists around the world have agreed upon, so you're admitting that you believe it because you think physicists agree on it, even though you don't know what it is, which would mean it's by definition a blind belief.
You don't know how to use words because you said 100% true. These are either true or false.
Blind belief? Is it just?
There's no such thing as 99% true.
You believe it even though you don't know what it is that you believe. You just like the sound of the overall picture. It's a blind belief.
If that's your definition of blind belief, believing that something exists even though you don't understand it fully or what it is.
No, you don't understand it fully.
Yeah, sure. I mean, I would say a blind belief isn't that. Most people, when they say that, they think of faith. Believing things.
That's what you're doing.
No.
Yeah, you know nothing about it. You're basically saying that just because I think maybe it's probably being said because some physicists agreed upon it. And enough agreed upon it that it's probably true.
Yeah.
So you must realize that is different from what you said a blind belief is, which is believing in something even though you don't know what it is. Faith is believing something without evidence.
No. Do you not know what the word blind means? It's when you can't see something. So you don't even know what it is that you believe.
Sure, but you.
So where's your evidence for the curvature of the Earth? Where is your evidence that the Earth is a ball?
Because I can tell you the
Why
evidence.
Why are you trying to give him like a out?
Yeah. Let's just talk about this. We don't need to talk about random stuff. Like, let's just talk about this. So the evidence in this case, which is why this isn't faith, is that it seems like if that's the scientific consensus, then that's something that seems like it's got a lot of evidence behind it. Doesn't mean it's completely true. I mean, scientific consensus can change, but I'm not saying it.
Scientific consensus is
I know
a paradox.
for 100% certain it's correct. It's something that has weight behind it.
How do you know it has weight behind it when you don't even know what it is?
I don't have to know what it is because the thing is that the evidence is scientific consensus, right?
How do you know what the evidence is if you don't even know what it is?
You're literally appealing to that. Like, what?
Wait, okay, let's see if we can actually get through this. Right? How do you know what the evidence is? I'm not. All I'm saying is the fact that it is the scientific consensus is evidence. Can you see that?
That's not evidence.
It's a logical fallacy. Appeal to consensus. It's not evidence at all. So yeah, you have a blind belief.
But consensus is evidence. It's like
no, it's not evidence. That's a fallacy.
You can't make up definitions for words; they're already defined.
Okay, do you not know? Okay, it uses an appeal to the beliefs, tastes, or values of a group of people, stating that because a certain opinion or attitude is held by a majority, it is therefore correct. That is an appeal to consensus.
Hey, everybody's jumping over a cliff, right? So you're gonna jump over a cliff.
Can I get Pinky to read out loud? Can I get Pinky to read out loud what I've posted in the live stream voice text at 16 past the hour? It's a quote by Michael Crichton. Could he please read it out loud?
You can read it out loud if you want.
Okay, let's be clear. The work of science has nothing whatever to do with consensus. Consensus is the business of politics. Science, on the contrary, requires only one investigator who happens to be right, which means that he or she has results that are verifiable by reference to the real world. In science, consensus is irrelevant. What is relevant is reproducible results. The greatest scientists in history are great precisely because they broke with the consensus. There is no such thing as a consensus science. If it is consensus, it isn't science. If it's science, it isn't consensus. Period.
I.e. paradox.
It can be religion, though, if it's consensus. So congratulations.
I don't know. Who wrote that? I mean, I disagree with that. I think there is such a thing as science.
Well, we have a consensus on it, so you can't.
Well, this is funny, though. Do you not know what?
In terms of knowledge, the fact that if you live in a society where there's
consensus wrote that.
There's no so the scientific consensus is built upon people criticizing each other in the scientific community, not just blindly agreeing with those in authority. And also,
let me just expose it. First of all, they admit they don't even know the cause of this. They have no idea how to explain it, and they can't even physically measure any of the three wobbles. So you're wrong again. You blindly believed it because I informed you that's what your belief has to be because you have a religion. It's like I can pull the Bible out and tell someone what they have to believe. They say that the Bible's real. Okay, so I got to inform you about your belief without you even knowing what it is. You still believe it to be true. You literally used a textbook fallacy, which is an invalid argument. That's what logical fallacies are. And you said that because there's a consensus, it's therefore acceptable to believe it. It's just a blind belief you have, bro. Can you just admit
if you're going to make an argument, like in terms of logic, like like A equals B, therefore C, then I'm just saying, a lot of people believe in it. That means it is definitely true. That doesn't work if you're talking about logic. But what I'm doing is making a probabilistic argument.
You're making an illogical one. That's what you just described.
Listen, guys, just listen. I've never seen DNA before, right? But there seems to be a lot of consensus. A lot of things are built upon DNA. The fact, like,
that's not how this works, right?
Guys, just
that's
listen.
not
Everyone with me, guys. So you don't need to talk about it. If I
No, we know what you're saying, man. Like, you're the one who doesn't know what you're saying. Okay, you don't even know the meaning of the word consensus.
I'm just responding.
Define consensus.
So there's a lot of biology. There's a lot of in terms of figuring out things about the world, but also just medicine, like gene therapy, CRISPR, that has to do with genetics, right? And DNA.
Wow.
Now, I've never seen DNA. I've never done my own experiment to see
Listen,
if it's there.
Stop talking. Stop talking. Stop talking. Stop talking. Stop
And so
talking.
if I please just
stop
listen.
talking.
I problem. I will not speak for the next 2 minutes. Okay.
Stop talking. Let me ask you a question.
You guys are asking me.
Listen. Hold up. Stop. Do we need a consensus, okay, to identify a basketball as a sphere? Yes or no?
Do you want that? Okay.
We're looking at basketball.
Let me just say that.
Do we need the majority of people to agree that it is a sphere in order for it to be a sphere, a basketball, a bowling ball? Yes or no?
I will answer that. But before I do, let me just say I'm answering all your questions to the best of my ability. But just let me at least answer them. Not just like.
Can you identify that this bowling ball is a sphere? Yes or no?
I prefer not to
no, guys, you have to just call out the fallacies. Pinky, you can't finish because this is a red herring fallacy, and your argument is about solipsism. It's a philosophy that nothing can be definitively known. So since you used the word definitively, then somehow it gives you an out, and somehow you didn't commit the fallacy of the appeal to consensus. But you did. You said it's true because it's the scientific consensus. It's the definition of the appeal to consensus or majority, specifically argumentum ad populum. It's a fallacy. Then you use a red herring and then on solipsism.
No, so those arguments, those logical fallacies, those are those offer more to do with logic and stuff.
You can't hide it behind probability, dude.
Okay, so now listen, he's throwing logic under the bus now. Good job, buddy.
No,
you literally have no knowledge of what you're talking about. You're arguing a stance of ignorance about something you don't even know about.
Exactly,
how about this? Everyone seems to disagree with me. I won't speak for the next 5 minutes, but just allow me up to 1 minute now, okay? The argument from probability comes from this sort of point, right? Given you find yourself in a world in which there's consensus built upon things like, say, DNA, for example, and there's many different entities, governments, companies. There's a lot of money involved. There's no particular reason why everyone would lie about this thing, and everyone's trying to disprove each other and get more correct about the situation.
So now argument for me
in a world where but the consensus is that people believe in DNA.
Okay.
That it's much more likely that DNA exists, right, than not. For start, I mean, you could say that there's some amount of probability.
Do we have to listen to you give us 2 minutes of fallacies at a time? It's another appeal to consensus.
We're not talking about electrons. We're not talking about electricity or electromagnetism. Okay, we're talking about the shape, okay, of a sphere.
Hey guys, I haven't talked all night. Real quick, I just came in because I think I might be able to help. I've DM'd with Pinky a little while back, and I looked back to see what we were talking about. I think that you might have some your profession, I think, is in the genome project or something like that. Is that right, or you're just interested?
Oh, it used to be. I switched.
Used to be. Right. Okay. Well, anyway, I think that a lot of that. I think it's interesting because the sciences, aren't all bunk, and I think that the tendency is to think that if we're right, then they're going to have to doubt all sciences as a whole, and it's so well constructed that there's a lot of fallacies involved within each of these disciplines. Regardless of the larger fallacy of maybe the shape of the Earth. But I think that you don't have to throw it all out, Pinky. Like there's certain.
We're not even talking
intelligently designed.
We're not even talking about science, right?
Right. But I'm saying that I think he thinks, or he kind of feels, and a lot of people do that are in the professions when they get encountered with the idea that they might be lying about the shape of the Earth, they feel like, well, then I'd have to give up my attachment to the other sciences that I'm, actually professionally involved with or have an interest in and can corroborate evidence I'm finding in the lab, which may all be true. It doesn't mean that the Earth's a spinning ball. So, but it kind of has that association, and people are made to think that if they doubt something like the shape of the Earth, they might as well not even be in the science, right? This is about protecting science. Like, Pinky, if we're right about this, right? It's about protecting science from pseudoscience, right?
Yeah, don't throw the baby out with the bathwater, right?
Would you at least say that?
I'll let
we're right about this. It's all about protecting science, not trying to destroy it or deny it. Because if it is a pseudoscience that's posing as real science, then this is about the value of science, not about devaluing it.
We're trying to keep it pure.
That's what he's demonstrated right now. He's trying to dress a bunch of fallacies up as science. Doesn't have any evidence, so he's just trying to pass fallacies off as evidence instead. So.
Well, yeah, he's going through his own process of trying to he thinks still that we must be wrong because science couldn't be lying that big because there's other things that he's cooperated or he's involved and maybe it would make him doubt. I don't know. I want to hear him though. Pinky, do you think that Am I hitting it on the? Can you at least admit that it is about protecting science? If we're trying to get rid of the pseudoscience, that's obvious.
Oh no, I understand pseudoscience is bad, and also I understand that just saying that most scientists believe in something is not a proof that thing exists. For instance,
of course not. No one's saying that.
Annoy some people in here, but most scientists used to believe in the geocentric model of a thing. Maybe I should have done that. Most scientists used to believe in lots of other stuff that is no longer true. So it's not a proof. These are not strong arguments. Like the thing you have to remember about these informal fallacies is that all it's doing is showing that we don't know for certain that this is true. But saying that there is a scientific consensus does provide significant support.
The fallacies show that you have no logical pathway to your conclusion. That's the problem.
Pinky, do you even know what the scientific method is? Can you walk us through it, please?
Well, before we do that, I wait real fast. I have to go to bed because I have to get up to work out in 4 hours. So I want to say one more thing. Okay. Here's the summary of what you're doing. This is just the facts. You know it's the facts as well. You believe that the Earth is a ball. You believe the current model, and it's because you think that there's a bunch of different quote-unquote scientific fields, and they've all done the work for you, and that you just trust them, right? Okay, that's how you look at the whole thing. So when I had to inform you that there's actually 3 different wobbles simultaneously happening, thus defying physics, and you couldn't explain it, you said you've only heard of the first one, but you automatically internalized and believed the other 2 as well. Okay, and this is called blind belief. You don't have any empirical evidence. In fact, your side says it can't be measured. None of the 3 can actually be measured nor explained. It's not even fully agreed upon on what causes any of these, right? They just fluctuate with, mass distribution, maybe. We don't know what it is. Okay? And the mass distribution explanation doesn't work because it's too consistent of a cycle, and they can't have mass distribution consistently, whatever. The point is that you don't know any of this, but you blindly believe that it must be true because the globe model claims it and needs it to be true to exist. So you're in a religion. You need to face that. You need to look in the mirror and realize that you just believe something that you don't even know or understand, bro. Okay? And that's effectively a religion. You need to come to grips with the reality of the situation.
All right, so I'll just, if I could respond to that before we go, as I said before, there is a difference between believing something in something without evidence and believing in something even though you don't, know all the details of it. If there's evidence there for something, that's all you need for it to not be a blind belief, unless that's not your definition of it. If your definition is the whole not knowing the details of it, then yeah, it's blind belief. But I don't know if that's a useful definition.
If
but
you don't even know what it is you believe in, then that's blind belief. If you don't know what it is you believe, but you believe it, that's blinded, dude.
If you don't even know what it is, Pinky, if you don't even know what it is, how would you know what the evidence for it is?
No, the evidence I've already explained. You guys,
you don't know what it is. How do you know what the evidence for it is?
Because I know that apparently there's someone's told me that it. If it is the case that there's scientific consensus on it, then it seems that I should probably.
Okay, under appeal to consensus, somebody told you.
Yeah, Witsit told him.
Yeah, the quote-unquote evidence is that the stars don't match the model's prediction relative to the solstice and equinox, that the moon doesn't match its prediction based on what's supposed to happen. Okay, that's the quote-unquote evidence, and that you have irregularities that they claim happens every year or a century and a half or so. Or no, year and a half or so, okay, with their claim of the axial rotation. So it's just 3 different scenarios in which the globe model's prediction doesn't match reality. Believe it or not, the discrepancies in your model and in your theory don't equate to evidence. This is like saying, since gravity predicts this, but we see something completely different, that's evidence for dark matter. No, it's evidence that your theory is stupid and not correct. So you're committing so many fallacies, it's overwhelming. You need to step back and think about what you're doing. Anyway, nice talking to you guys. I gotta go to sleep. I'll catch up with you guys later.
Catch you with it.
Night.
Peace out, what's it?
Yeah.
Later.
Classic Texas sharpshooter fallacy. That's what it is.
Yeah, you don't get to shoot your arrow and then draw the circle around the arrow.
But all he's doing is just using the exact same fallacies over and over again, just trying to dress them up differently. It's just another appeal to consensus. When we asked him, okay, well, how do you know what the evidence would be if you don't even know what it is? Oh, because this guy said so, and they all agree on it. It's the exact same thing over and over again. He just keeps trying to spin it some different way.
I think.
Well, he's usually relying on information. Like, what you don't mind me asking, Pinky? What did you switch from when you got out of the Genome Project? What are you in now instead?
Oh, well, that's actually why I have these beliefs and why beliefs right now about the whole scientific consensus thing. I basically do statistics and data science and computer science.
Okay, yeah. So if you weren't able to trust the information that you're getting, like you can't go corroborate all the information you're getting to do statistics. I mean, that would be kind of a crisis for you to accept what we're talking about, because then you're like, wait a minute, okay, these are just numbers I'm getting. How do I even know if these are right? Are they cooking the books before I'm able to acknowledge? How am I supposed to validate what I'm doing if I can't even trust the numbers they're giving me? Right?
So, let me ask you a question in your perspective. Do you know how I'm talking to you right now? Can you tell me how?
You mean, okay, wait, now this
don't say satellite, bro.
I think you're getting towards, like, maybe it's because we can't see something doesn't mean it doesn't exist. Is that what you're talking about? Are you talking about satellites?
What's going on? How am I talking to you? How is the information getting from me to you?
The ether.
Fiber optic cables.
It's a false analogy anyway. It's a false analogy anyway, because you're talking about the how something works, right? You don't even have an observed phenomenon to start talking about how. You don't have a tilt that you can show us to start talking about how does this or that. You don't even have that.
Well, the thing is, like,
I wonder though. Do you think that it's instantaneous?
No, but listen, new perspective.
Do you think that there's like right? Dude, I just wanted to ask you this: do you think that the sound's coming out of your mouth, going through a wire, and traveling all the way to me, and we have to wait for that time for it to get to me before I hear it?
Yes.
Or do you think it's instantaneous?
I think it's definitely takes some time. It's not the speed of light.
But you think it goes from A to B, right?
Yes, and I think.
Have you considered that?
You're responding pretty quick to him. It's almost instantaneous.
Listen, new perspective. Because I'm going somewhere with this. Like, do you think that there's an underwater cable going under the ocean connecting me?
Well, that's not a like conspiracy theory. That's
what do you mean? Do you think?
In some places, yes.
Saying, right?
So
why is that something that?
Hold up. So underwater fiber optic cables travel at the speed of light. Okay, like, do you think
he's saying it goes through the cable instead of going instantaneously?
So, because do you think I'm using Ravens, or do you think I'm using a fiber optic cable to?
Everyone is using a fiber optic cable. If you're responding as fast, of course. Do you know the latency of it?
Okay, Pinky, what are you using this?
Your argument.
It doesn't matter.
Okay, fine.
What are you using this? What are you using this as an analogy for? What is your analogy for?
No way. Let him build. Let him build. Okay. Okay, go ahead.
What's the analogy for that? Let's find out what the analogy
is. That you, Pinky, you know that recently they've announced in the science world that like the electricity doesn't really travel through the wire, right? You've gotten that.
Oh yeah, I already know. I already know that, but it's fiber optic anyway. But,
why are we descending into this derivative stuff? Why don't we find out what his analogy is for? What is this analogy for?
Well, so I just say, new perspective. So you'd say that you have some confidence that there is a fiber optic cable, right, going under the Atlantic.
Oh my God!
I'm not.
What are you trying to say, Pinky?
The Discord conversation, Pinky. What is it analogous to?
I'll just move on to the point. Thing. So a lot of people in this call have been saying, "Oh, there is a fiber optic cable." The thing is that have you seen this fiber optic cable, or are you just relying on the consensus that there is one?
I have seen that.
Yeah, I guess I can't confirm it, but I mean that there's no reason to.
I have seen the fiber optic cable. 2014, we laid the fiber optic cable down to Americans.
Yeah, like what do you think the benefit of them lying about that would be? Like, do you think the fiber optic cable is like to throw people off?
It might not be there. Are you crazy, stupid, or something? It might not be there.
Well, he's saying
why it's there, okay? Because without it,
we haven't seen it personally. Doesn't mean it's not there. I get it.
Yeah. So I promise I will stop after. Like, this is one more minute here. The thing
there's no probability that it's not there.
The thing is that you guys are saying, "Oh, you just read a Wikipedia article, and now you're going to say that this thing is true based on scientific consensus."
I want to ask.
Well, first of all, you're speaking to people who have experience, hands-on experience.
You're kind of missing the big picture, though, right?
Okay, but the thing is that
it's not like we're just idiots that are making like. You can't just say, "Oh, well, you think A is B, so now you have to always think A is B," when it doesn't really apply in the same way.
No. The thing is that, and this is my whole point, and I'll wrap it up here, is that there's so much stuff. In fact, the majority of stuff in this world, you believe based on the fact that you've been told it is the case, and it's scientific.
No, we don't believe. No,
hey, even if that were true, though, Pinky, we're talking about common sense here, right? Mm-hmm. This is a battle between common sense and consensus. And if consensus isn't including common sense, there's a problem. And that's what we figured out. And you think we're just idiots here going, well, it must all be true because they must be lying about everything because we know it's flat because we were told it's flat from a YouTube video. But you've been involved in this conversation long enough to figure out that's not the case. These are intelligent people you're talking to.
No, I know. I'm just saying people are saying I'm making a fallacy of some kind by saying that there's evidence behind it.
Well, you've used our fallacies, Pinky. Face it. That's all you've done this whole time. You don't have one single logical pathway to your conclusion.
Pinky, at least hey, good on you for at least sticking around and not just disappearing like you almost did. And at least you're engaging in the conversation. I mean, you do want to know if it's true or not. Like you want to know if you're actually on a spinning ball or not. Like you really want to know, right?
Well,
or would you rather just do it? Give an honest answer. Let him give an honest answer. Would you rather? Do you want to know? Do you really want to know, or would you rather assume that you're on a spinning ball?
No, he wants to know.
I really, honestly, if you changed my mind on that, that would be the best thing that anyone's ever done for me, to be honest. Because like if you then my world of the universe gets to be more correct, and I really do want that. I mean, I want to know these things, so I am listening.
This is what intrigued me about you before. Now I remember. Now, that's interesting. Like he's one of these guys that's saying that he would be happy if we're right. You know, and that's the thing, right? But then Occam's razor is pretty powerful, man. Occam's razor cuts pretty deep. You know that, right?
Yeah.
Let me ask you.
You know what? Would you be all that surprised then if I told you the reason you don't feel like you're spinning is because you're not?
Let me.
Oh yeah,
Well, that's pretty blatant, right? That's all you really need. But if you want to look at the details, we can show you plenty of them. We're not idiots. We've been looking into this for 7 years. If we were on a spinning ball, believe me, we would have found out.
New perspective. Can I ask you?
Let's let Sheepdog get his question in so he can get that out of the way. Go ahead.
Can I say something real quick? Hold up. The point is, you don't have to believe. You don't have to believe what anyone says or what you read anywhere. But you gotta believe something, right? And you have to believe something, why not start with what you think is real and should be real according to your experience? See, you're gonna have to believe something, all right? And it doesn't have to be this globe Earth model, even though it goes against your senses. So do you understand that? There's no probably a ball or not a ball. It either is or it isn't.
So it's funny you said that, because I just posted a video, which you guys can probably watch it on your own time, which explains the way I'm going about how I view all the propositions I hold. It's not like I hold a bunch of binary true, false propositions about things. Really, there's very few things I know for certain, right? Like,
I know you're gonna like this logic. Hold on. You're gonna like this, okay? Because this is also falls into what if ball, okay? If ball, then curvature. You see how that works? If this, then that, right? If this is a ball with this radius,
he's telling you he's not working off that ball.
Then it should be curving at this rate. Okay, and we shouldn't be able to see farther than this distance to the horizon. You understand?
He's telling you. He's telling you he's not interested in logical syllogism. That's what he's saying.
That's not true. So when it comes to truth statements about things like that are abstract, like math, where you define everything. So you say, if I define what a sphere is and it has this radius, then the horizon should be this far away.
It's not math.
Then you
it's
can
not math. It's not math. It's logic, right? It's like,
well, that's the same thing.
If this, then that, then then the feature.
Yeah.
So if a man, right, then penis. If a woman, then vagina. If a zebra, then black and white stripes, right, and looks like a horse.
If you define one, and if you define the addition, and then if you define another one or two, then you can say then for certain, then you can use syllogisms.
Pinky, are you making a case for not using logic to defend your globe claim?
No. I'm saying you can use you can use logic to make certain statements about stuff where for 100% certain if you define everything, or if you have some unrefutable empirical evidence. But for most of the arguments that people make, like for example the whole scientific consensus thing, that's more of a probabilistic argument.
That's not logical, so it's invalid. Do you have a logical argument to make for your worldview?
What's the difference? What's the difference between a straight line and a curved line?
Oh boy!
Wait. Hey, get this right. So you say the Earth is flat, water is level when at rest. Do that with the globe. Try that.
So with I could post something.
Just do it, man. Just say something that is logical that I like what I just said. That matches the globe.
Yeah, you spent all this time fighting logic. Bring us some logic in support of your conclusion.
All right, so
here we go. You want me to repeat it, or you're just going to do it?
No, this is a good exercise.
Just do it.
The best way to explain this to you, but so essentially, what you can do is
explain it. Just do it.
Well,
the Earth is flat. Water lays Water is level when at rest. Do it with the globe.
Yeah, like put a ruler on a basketball, right? What do you see? So water is the ruler is the water, right? And the basketball is the globe, right? What do you see? The water doing, the ruler doing on the basketball, right?
Right. So in this case, what you do is you'd say, assuming that the like say if I'm on the planet, if all my senses aren't lying to me, and it seems to be that this Earth is a globe. Conceptually, if there was a globe and that there had water and there was gravitational attraction, would it match?
Why would your senses
Hang
tell?
on a minute.
Which one of your senses?
Spartans! What is your profession?
See, old friend, I brought more soldiers than you did.